Hello, everyone. Gravity Max here. And today we have a guest for the first time on our live stream. So, yeah.
Please give a warm welcome to Youie Films, aka Brendan McGinley.
Hello, that is me. My name is Brendan McGinley.
Nice. So, thank you for coming on the show, on the live stream. It's great to have, just spice things up, right? Have a third voice every once in a while.
Yep.
So, today we'll be talking about the periodic table and just, various, how it works, stuff about the elements. It's going to be pretty cool. And I guess we'll just, wait a little bit for people to start coming on.
Yeah, I gotta do my classic opening of the stream in the background.
I am also going to be doing that.
Yeah, I just did that.
So if you suddenly, if you have, I forgot Gravity Max roller coaster.
Oh, yeah. Yeah.
Salt.
Gravity Max roller coaster. We don't talk to them. We don't talk about them. They're yeah, I don't know. What company is it? Gravity Max.
I don't know.
Roller coaster.
Yo, I'm hearing the echo of the stream coming through someone's mic.
Muted.
Not my mic.
Boomer.
I don't have it open on my computer, so it's Li Pao Land in Taiwan. So, or wait. Oh, I mean, it's not in Taiwan. It's in Chinese Taipei. Just gotta, Anyways, yeah, so that's where it is. Taiwan and/or Chinese Taipei, depending on how you see that issue. Yeah, so before we get banned in international territories,
I was gonna make a joke on that, and I was like, hang on a second.
Yeah, before we get banned,
this isn't my YouTube channel.
Yeah, so before we get banned, we'll start the stream.
Let's.
Yeah, okay. So, first slide, we have visit the Gravity Max website and follow Gravity Max on social media. I put links in the description, but they're not yet in the description. They'll be in the description after the stream, just a little bit after. So yeah, but this is just, I have Facebook, Instagram, and Twitter for Gravity Max, where I just kind of announce when there's a stream, I guess, if you want reminders. But it's pretty consistent.
Just to clarify, you do want reminders.
Yeah, it's
a good stream.
Yeah.
It's a good stream.
Yeah, it's every Saturday at 7, so I guess, if you can remember that, then I guess you don't need reminders, but if you can't remember that, then make sure to join these, follow these accounts.
In fact, 9 out of 10 doctors recommend following Gravity Max on social media.
9 out of 10. Is this a peer-reviewed study?
It is.
Oh, cool. Okay.
It's FDA approved.
There's
FDA
always that
approved.
one guy in each study that just does not agree.
What?
Did I send you guys that article of the lab rat that they've used it in multiple studies, and it very consistently sees what the other rats are doing, can detect it's in a study, and does the exact opposite of what it's expected to do?
What?
It is one of the funniest things I've seen.
My first question is, how has it survived all these studies? Because, aren't they pretty brutal?
No.
It
was funny, though. That's
pretty crazy, though. Stick it to the man. Okay. Anyways, next slide, we've got a second plug of the night. Buy the book. It'll be on Amazon this November. I'm thinking, Thanksgiving Day, probably, is when it'll be up. It's all finished. I could put it up today, but I just need to get some press hype so that it doesn't end up a commercial failure.
And I mean, let me tell you, boy, am I hyped. Yeah. I have never been more hyped for a book in my life.
I've already pre-ordered it, and it's not even
I'm honored.
In the stores yet.
I am honored.
Is it pre-orderable?
No. You can.
Wait, is it pre-orderable?
No.
I don't think.
I think I made that up.
You should.
Yeah, you can't pre-order. Amazon has this thing. I was looking into the publishing process. It's they don't let you publish like paperback books, I don't really know why. There's like something you can do, but I'm just like, forget it.
Why don't you just send me the Google Doc you made it in, huh?
That's
Max?
true. I could send you the Google Doc for free.
A .txt document.
A .txt. Honestly, oh my gosh, TXT documents. Just no formatting. But yeah, just buy the book, sci-fi book. Very like based in science, hard science fiction. Not just like anything goes. Yeah, it's pretty fun.
All right.
Cool.
Can I give a... So, when Max was still in where I am and going to our schools, he was writing this book, right? And I see him designing a full, like, moon rover or something like this. And I'm like, oh, why are you doing that? And he's like, oh, I'm going to add one in my book, and I want to design one first so I understand how it works before I use it in the book. This book is so detailed. Like, the amount of thought you put into it, you definitely should go get the book. From what I've seen, it's an amazing book. Go get it.
Thank you for that. Thank you. That was very nice. Thank you.
Official testimonial.
You
can PayPal me later, by the way.
No, I don't have PayPal. Sorry.
Venmo? Fisco?
No.
I just made a change to one of the slides.
Oh, okay.
Hit present and then present again so that it loads in because it's very crucial.
It's very crucial? Okay.
Very crucial.
Okay, so I did that. So should we go on to the next slide?
Yes. Yeah, it won't show up in a little bit, but it's crucial.
All right. So we've got the periodic table. This will be our topic for tonight.
Yep.
That is crucial.
No, that's not the change I made.
Yeah,
that is Dmitry Mendeleev, who is the creator of the periodic table.
No. I was looking at something further down. But yes, that man.
Yes. So the periodic table is defined as a table of the chemical elements arranged in order of atomic number, usually in rows, so that elements with a similar atomic structure and hence similar chemical properties appear in vertical columns. Basically, what it means is that it's a grouping and organization of all the elements that we know of.
Mm-hmm. Yeah.
Elements are the base building blocks of the universe. Once you start to remove parts of an element, it ceases to be that same element. So it is one of the most basic things in the entire universe.
And it's crazy how, even though it's like one of the most basic things, we still don't know that much about them.
Mm-hmm.
Like, just a few years ago, we thought that it was just like a ball in the middle.
That's true, yeah.
Mm-hmm.
We've just recently gotten the quantum model. But yeah. And also, for any of our fans that might not recognize this form of the periodic table, this is the long form of the periodic table. It isn't often like seen because it is inconvenient. But we're all about inconvenience here, right? So, basically...
That's why we're on Saturdays at 7.
It's my mom's birthday today. She's at her birthday dinner.
Did you skip your mom's birthday?
Welcome to the stream.
I mean, you didn't? Okay. Sorry. I mean, if you want, we can change the time, like in the future for future.
No, we're doing her actual birthday dinner tomorrow. Don't worry.
Oh, okay, cool.
I'm not actually missing anything.
Okay, good. I was beginning to feel guilty. Anyways, yeah. So the green rows, those are the actinides and the lanthanides, which we'll talk about a little bit later. But usually they are kind of like replaced with an asterisk and like
pushed off to the bottom.
Yeah, underneath the table, because it's just the aspect ratio is much better that way. But here we've just kind of like made it skinnier so that it fits on this presentation board. And this is the true form of the periodic table. That other way is like, I don't know, it's just easier, but you know. Anyways, so Mendeleev, when he first made the table, he was doing it in order of atomic mass because they didn't know that protons existed yet. So they were just like, the element weighs this much, so yeah. But he had some problems because if you actually take a look at the table, I think it's iodine and tellurium, right? Iodine is after tellurium, and it has a higher atomic number, but it has a lower atomic mass, which is just weird. So it has the properties of a halogen, and so he grouped this by chemical properties, and that's where we get our modern conception of the periodic table. But he was like, isn't this weird? This is like a violation of the rule of atomic mass order. So he's like, I don't know, must be something. And then they discovered protons and were like, it's that. And they didn't really rearrange it, but they like said, okay, it makes sense if you put it in atomic number order. So yeah, that's a little history. All right. Should we go to the next slide?
That is a good fact.
Okay.
All right, so let's head over to the next slide.
Yeah.
We'll explain.
Okay, so these are the main group elements. The main group elements. These are the ones in the red and the orange areas of the periodic table in the last slide. So the red and the orange columns, those are these columns. These are all your familiar elements. This is most chemistry occurs here. You've got some really unique characteristics for these elements, whereas the other elements are kind of a lot more similar and don't deviate in their properties as much. You've got a lot of fascinating stuff here. So these elements are filling up the S shells and the P shells in their atomic, their electron orbitals. So the first two on the left are the S shell and the rest are the P shell. And pretty much the way that they fill with their electrons, the number of electrons that each element has is really indicative of its chemical properties. The nucleus is really just, it's the nucleus, nuclear properties, right? Nuclear energy or whatever. It's not about the nucleus when you think of all of the chemical reactions and stuff. So yeah, these are just some really interesting elements. These are the ones that you focus on the most.
Yep.
Yeah.
You said it.
Great.
Do not have anything to add to that.
Okay. I'll say less.
No.
Yeah.
This is enlightening.
Oh, okay, cool. Yeah. Great. So I'll go to the next slide. So here we have
hydrogen.
Hydrogen. Yeah.
This is, okay, hot take. Hydrogen, most interesting element. Just, it's a fact.
Well, here's
what do you find
an
interesting
fact.
about it?
Scientists estimate that hydrogen makes up over 90% of all the atoms in the universe. That's a lot of atoms. That's more than 2 football fields.
Wow. Wait, what?
Is that more than
That's more than 2.
Yeah. Mercury?
Is it more than what?
That's my unit of pressure. I use square-rooted acres of mercury.
I would say it's a little more than that.
I'm confused. That's a very odd unit. Oh, wait. So
it's a very practical unit.
Did you know that 10% of the mass of the human body is hydrogen? I sure didn't.
Well, there it is.
Did you know that hydrogen is a great fuel to use in a blimp?
Oh, okay.
No.
Hang on.
No, that is actually false.
All right. So hydrogen engines are what we are going to be able to replace gasoline engines with, right? And here's my idea. You could use HHO gas, right? Because you could break the bonds of water with electrolysis and make HHO gas, which combusts really easy, and it's an exothermic reaction, and also it explodes and stuff. So theoretically, you could run an engine off of it. But the problem is hydrogen is so small that it can dissipate through pretty much everything. And then it embrittles the stuff it's in.
Yeah. That's definitely a difficulty.
Still, hydrogen engines are the future.
Yeah, because their waste product is just water, right? Their waste product is just water.
If you combust HHO, it reforms the bonds, and it just becomes water.
Yep, H2O. I have heard, though, that it might not be as, environmentally friendly as, people think, because it puts, water vapor in the air, which is also a greenhouse gas, but, I don't know. Maybe it's
Okay. But
Maybe-
the difference with that is, yes,
Yeah.
water vapor is a greenhouse gas.
but then it becomes water.
When there's too much of it, it rains.
Yeah, exactly.
That is not a problem. That is fake news.
Really? I don't know. I've heard differently.
Hydrogen is one of the main elements of organic chemistry.
Mhm.
If you are studying biology, you're going to hear about hydrogen a lot, specifically in relation to nucleic acids.
Yeah.
And these, of course, they're what make up DNA,
Mhm.
and they obviously play a massive role in all life on Earth.
Uh-huh.
So hydrogen is definitely one of the more important elements,
Yeah.
even if you couldn't gather that from it taking up 90% of the universe.
Yeah. Well, basically, the thing
That's
about
not that much.
hydrogen, right?
It's a little bit, I would say.
It's like maybe 3 football fields.
Give or
So-
take, yeah, I would say.
So the thing about hydrogen, right, is that it's kind of like a filler substance that allows a lot more molecules to be made, because hydrogen basically, it's super common, as you said, 90% of the universe, and it only needs to make one chemical bond to have a complete electron shell, because it has one electron and it wants two to have the stable configuration of helium's configuration, right? So it makes one covalent bond, which basically means that any molecule you can think of, if it's missing a few bonds, just throw some hydrogens on there and you're good, that allows
Just slap some on.
Yeah, just throw some hydrogen in there. It allows you to make a lot more. It allows, organic chemistry is primarily based on carbon, but hydrogen is really important in it too, because it just allows for so much more diversity in the molecules you have, because otherwise you wouldn't be able to make as many, and then you wouldn't be able to have as many enzymes and chemical reactions, and life probably wouldn't.
And
be a
that can
thing.
connect to biodiversity, because it allows for more species and just more animals in general.
Yeah,
You know,
we've got
without
some
it,
beef. We've got some history with biodiversity.
Yeah.
Yeah, we have some interesting. It's tough. Oh my gosh. Anyways, that was 2 years ago. We had an interesting science project, and we for school it was a science fair type thing, and we had to relate it to biodiversity, even though it wasn't related to biodiversity, because the
It was
school
not at all.
yeah the school mandated. They were
It was a solar cooker. We were making a solar cooker.
yeah, so it's pretty much just a thing that concentrates light to heat something up, right? And so the school just had this mandate that they recently added of you have to relate it to biodiversity, and we're okay. So we did, but it was rough. We
It was a fun time.
yeah, we just made something up.
I would like to address the chat
Oh, the chat?
for the
Yeah.
first time this episode.
Mhm.
Oh,
So I would agree with one comment left by Youie Films. It says, "This Youie Films kid sounds cool. I want to subscribe."
Okay.
I would agree with you, Youie Films.
Huh.
And
I
our
wonder
friend,
who this Youie
I
Films
think that
is.
is commented
I
on
think
every
so.
stream. I don't think I can give my opinion on your second comment.
yeah, no, I actually don't agree with that one.
You don't agree with him. We've got some drama.
I don't agree with that
I don't
707.
think I can legally agree.
Maybe we
with
can have him on.
that
Maybe we can
second
have him
statement.
on at some point. in
I
the
can
future.
confirm there would be a
And
lawsuit.
You guys
for
can
defamation.
debate. You can debate.
Ooh,
We'll have
that could be a
segment
special.
in the future. It'll be a special.
Christmas special.
Christmas special? I don't know. I thought
What
that
would
was.
we be debating?
It'll be a special, because our Christmas special or end of the year special is going to be for the
Oh, the equation.
equation,
Yes.
standard
Oh, the
model
equation.
It's really odd. You saw last episode, right?
Yeah. Our viewers definitely saw last
Yeah.
episode, but
You know what I'm
Brendan,
talking
if you,
about.
if you
I
wanna
saw
look it up,
every
it's
minute.
The equation.
a standard equation.
Yeah. Anyway.
Yeah, you
Standard
showed it to
model
me.
equation.
Yeah.
Yeah.
You showed it to me.
Cool.
I've seen it. It's
It's
Yeah.
disgusting.
Yeah.
Ooh.
So, anyways, so yeah, to just get back on topic, right? So
Yeah.
hydrogen, just the most basic element, and the fact that it's so abundant allows a lot more things to exist, a lot more molecules to exist, and that's hydrogen. It's like moderately reactive. It's just like very like tepid, and like it's just the basic stuff. Like
It's
I don't
like
know what
one
to
of
say.
those it's like one of those chill people that can pretty much become friends with everyone.
Yeah, that's hydrogen. It's just like
That's hydrogen. Yeah.
just use it like liberally. You know, you can just liberally spread some hydrogen on there. Just use it wherever you want. You know, yeah. So that's hydrogen, and it's on the top left of the table.
Yep.
Okay. So
So
next,
let's head over to the next slide.
so here we have helium and the other noble gases, including the most recent oganesson.
So these are known as noble
yeah.
gases, and like Max said, they're known as noble per se because they don't interact with anything.
Yeah.
They are very uptight, and they don't have any reactions with any of the other.
They don't
elements.
associate with the commoners.
Yes.
That's why they're noble.
They are nobility.
Yeah.
Well, this is the bourgeoisie, but they're antisocial bourgeoisie.
Exactly. Yeah, so this is the noble gases. Basically, they have the perfect number of electrons to just be stable and not need to make chemical bonds with other elements. So then they just usually don't. Although there have been some scientists, some chemists have synthesized like weird like compounds involving the noble gases at like low temperatures. So there was like, I think it's like argon, hydrogen, and fluorine, I believe, were made to react and form an element at like 18 degrees Kelvin. So it's like, yeah, so it's like barring very odd circumstances, just in everyday life, you're not going to find any noble gas compounds. They just exist just neutrally. Yeah, and actually an interesting fact is that since they don't really bond to anything, well, this is specifically helium. Since helium doesn't bond to anything, it's very hard to find it on Earth. It just floats to the top of the atmosphere and just leaves. It says, I'm a head out, right?
Yeah.
The solar the solar energy just strips it off the Earth's atmosphere, and then it's gone. So
It was something I read,
Yeah.
which I have not fact-checked to get this straight,
okay,
but it was something like, we have almost gotten through all of our helium reserves.
that's true. We are running out of helium. But the thing is, did you know that our source of helium is actually alpha particles from nuclear radiation? That's where all our helium comes from. So basically, when unstable elements, radioactive elements, when they decay, every once in a while, well, depending on the element, they either emit an electron or a gamma ray or a helium nucleus, also known as an alpha particle. And these helium nuclei, when they are emitted underground in like radioactive deposits, they just kind of stay there. And they often percolate, like they get mixed into like natural gas reserves underground. So the way that we first discovered helium on Earth, we first discovered it in the sun. But once we discovered it on Earth, it was in like natural gas deposits, and that's actually where we find our helium. That's how we get helium. So the next time you go to
That's actually really interesting.
yeah, I was like kind of shocked. It makes sense, but I was like, wow, all of our helium is just radioactive decay. So when you go to like Party
And
City,
it comes from underground.
yeah, exactly. When you go to like Party City and get some balloons filled with helium, you are actually filling balloons with radioactive waste.
Yep.
So
Can I
share
hang on
that
a
at the next
second.
party.
Could I become a professional helium miner?
I think so. So I suppose so. Yeah, I don't know exactly how it works, but it's probably an association with the natural gas companies. And however they retrieve that, then they just kind of filter it out, filter out the helium. Yeah,
Yep.
so that's how we get helium.
So
Argon
yeah.
is
Here's an interesting fact about helium
Uh-huh.
while we stay on the
Yeah.
element before we head over to argon.
yeah.
Helium is actually often mixed with oxygen in scuba divers' air tanks to dilute the oxygen. It is used instead of nitrogen because it will not dissolve in the blood and will leave the human body quicker.
That's That's good.
Thank you.
Prevents
So then do divers' voices on the radios, do they
Ooh,
sound higher?
that is possible.
How much helium are we talking here?
Yeah, what's
Are
the
they
percentage?
just sucking on a balloon or like?
No, it's just used to dilute the oxygen, so I don't know what the ratio would be, but it's
Because-
probably pretty high.
Because in the air, oxygen is only 20% of the air. So do they fill 80% of the air with helium?
That's probably true.
Well, that would be
Actually,
interesting.
Let me fact check that.
Yeah. So
Yeah.
I'm just going to quickly, so we'll go back to that in a second. So argon is actually a major component of our air. It's 0.9%. So argon is a lot easier.
That's a lot.
Yeah, it's a lot more common. And, you know, argon and neon, they use it in lights. They run electricity through it, and it excites the electrons. And when the electrons move from their excited state back to their ground state, they emit energy on just one specific color. And that's the color of, like, neon signs and argon signs. So, like, when you see an
Fun
open
fact
sign at a restaurant,
that I
that's what
learned
it is.
about
Yeah.
is that neon only, like the only true neon signs are the red ones,
Yeah.
and all the other ones are imposters. They're fake
Mm.
neon signs.
They use other gases, right?
Yeah, these other gases or just like
Mixtures too, maybe.
have lights in colored glass.
Oh, that's true.
So
that's
I
a
looked-
ripoff. I hate that when they
I
have just
looked at
lights and
the
colored glass.
makeup of a scuba diver's tank.
Mm-hmm.
So even though it said in the other thing that it is used as an alternative for nitrogen, nitrogen is still used,
Yeah.
and that makes up 78% of the tank. The oxygen makes up 21%, and helium makes up 1%.
What?
All right, so it's not as significant as we
Why
thought.
even bother
Nope.
though? Like,
Not indeed.
is the argon? I don't
Also,
know. Like, what is it?
argon is used in it as well, yes.
Oh.
But here's an interesting fact about argon.
Uh huh.
You ready?
Yes.
I actually got two for you, just
Okay.
for you, listener. So
Ooh.
first, when argon gas is combined with small amounts of mercury, it will glow with a blue color when excited by electricity.
Nice.
Ooh.
That's cool.
And here's the second.
Ooh.
Quicksilver.
When argon is used as a gas laser, it
Mhm.
emits a blue-green color.
Hmm.
Ooh.
Wow.
Gas
pretty cool.
laser?
Gas laser. You heard me.
Bruh.
That's pretty cool.
A gas laser is a laser in which an electric current is discharged through a gas to produce coherent light. The gas laser was the first continuous light laser and the first laser to operate on the principle of converting electrical energy to a laser light output. They are lightsabers.
Wow.
They are lightsabers.
Nice. That's pretty interesting. So,
Mhm.
so yeah. So just
That was 3 facts for you.
That's cool. So I'm just
It's more
gonna
than
go
two.
to the next noble gases, right? So we've got Krypton, which is the Superman planet, right? Is Krypton.
Mhm.
Yeah, Krypton is not a green crystal structure. It's just another gas, like clear. It's kind of boring. It's like all the others. So it's misconception from like Superman and stuff like that. Then you have Xenon, which Xenon is pretty interesting. It can like make your voice really deep if you inhale any xenon. But it
Oh,
can,
is that the one that does that thing?
yeah, because look, it's got 54.
Well, yeah.
So that like its atomic mass
Well,
is
maybe you
above
could do that with
100.
radon.
What? Oh, radon. Yeah, radon is. Well, the problem is radon is extremely radioactive. So there isn't enough of it to actually inhale. And if you did inhale radon, it would just like light your lungs on fire. It would not be a good time.
Ooh.
So yeah.
Sounds like an adventure.
Yeah, radon is only found due to the radioactive decay of higher elements, and it itself decays later on. So,
Instead of sucking down radon-infused air,
Mhm.
why don't you, on Saturday at 7 p.m. EST, hop on the Gravity Max live stream?
Gravity Max live stream.
Thanks.
7
Light
p.m.
your
Thanks for
lungs
that
on
non
fire.
sequitur. Great. Yeah, do not inhale radon. Watch Gravity Max live stream. That's great. That should be our slogan.
What would happen if you inhaled Oganesson.
Oh, okay.
I do not
Oganesson.
know. Sorry that I'm pushing this along, but I know nothing about Oganesson.
Okay.
Oganesson, well,
is
that's
it?
fine because it was basically just discovered.
It was just discovered. They don't even know. It's really weird. So the reason it's gray, whereas all the others are green here, is that Oganesson, along with some of the newer elements, they just have not determined its property yet. So although it technically it's got to be a noble gas just based on its position and electron configuration, they aren't exactly sure if it can be qualified as a noble gas because
It
might
walk
have
the walk.
Yeah, it might have weird properties. They just haven't had enough experiment with it yet because it exists for a millisecond. It's just it's odd. That's Oganesson. OG Oganesson. It's interesting. We have a slide for the newest elements a little later, but so we'll come back to that. So
we
next,
will get to that
Can
later.
we acknowledge the chat?
Oh, the chat.
We got
Sure.
a lot more in chat.
We'll check the chat.
We do. We have Daniel the Manual
Mm-hmm.
saying cool what oh and then oh.
Mm-hmm.
The Lesbros saying I'm late to this, but helium is fun to inhale.
It is.
Thank you, Lesbros. And Citrus Spit Space exclamation point saying okay nerd.
Okay.
And y'all sound like boomers or some comma.
Interesting.
I can't tell if that's 4 or 3 commas.
You see,
That's
I don't
3.
actually know who half these people are.
Yeah.
I know who all of these people
Oh,
are.
you do?
Yeah.
Okay, that's good.
They probably came from my advertisement.
Oh, okay. Well,
But
that's good.
anywho's,
I guess.
going back to the noble gases after acknowledging chat,
Uh-huh.
about half the noble gases are okay to inhale. The other half I wouldn't. But
Yeah, well, basically,
it's your life.
xenon and krypton, the issue is that it does cause some what's it called, anesthesia. It can cause you to pass out if you inhale it, if you breathe it for too long, because it's just
is this
so
a
heavy.
warning or an advertisement?
No, this is a warning. You don't try it at home. Don't try krypton and xenon inhaling at home. I mean, I don't know where you're going to find krypton and xenon because it's pretty expensive to buy xenon. But just don't do it. Don't try it. You'll be fine probably, but I don't want people to inhale xenon and then get mad at me. So don't do it. That's what I'm going to say.
Gravity Max does not condone the inhalation or production of krypton and xenon.
Yeah. All right. I'm going to go to the next slide.
That's going to be our slogan. Yeah, let's head over to the next slide.
Okay. So here we have the alkali metals.
The alkali metals.
And so here's the thing, right? Hydrogen, the reason why it's alone is hydrogen is technically an alkali metal. It's in the column. It's on the left side of the periodic table. It's this column on the very left. But it's not... It doesn't act like the other alkali metals. So people are like, okay, it's not an alkali metal, you know?
Yeah.
So
it's doing its own thing.
Yeah, it's gone rogue, you know. So
yeah.
So the alkali metals, basically, they are very reactive. That's their main property. They just react insanely. There are some very popular videos of just random people that aren't scientists, but like to put on glasses or whatever, just chucking a few pieces of lithium or some other noble gas into water. They like to do cesium because they're like, oh, it'll explode or something. But it's just basically they're very reactive, and the reason for that is that they have one extra electron because they come right after the noble gases. And so if the noble gases have a complete shell, right, then the alkali metals have one more than they need. And so they really want to get rid of that one electron. They just want to yeet it away, They just want to get rid of it. And so they do that very violently with other elements.
Yeah. Yep.
So
yeah, these are fun. This is my favorite group, just because of, the explosion.
Yeah.
And
I like explosions. Those are fun.
They are. honestly. But who wants to hear an
And
interesting
can be
fact about
educational.
lithium?
All right. What's
I
an
would
interesting
love to
fact?
hear an interesting fact about lithium.
I got a bunch for you. You ready?
Aren't they in phone batteries?
You got a
right?
lot of lithium facts.
I do. So, although lithium is a metal,
Mhm.
it is soft enough to cut
Ah.
with a knife.
Yeah. I've often heard a butter knife.
Dang.
Yeah.
So, lithium fires are difficult to put out. You can't use water as an extinguisher.
I think
as
that would
the
apply to
water
all
will
of them,
only
right?
worsen the fire.
Yeah, that would apply to all of them, definitely.
That's like magnesium fires.
That's actually a
Yeah.
problem because lithium ion batteries. That's what
Yes.
they use in like phones and like when
and everything.
yeah, but like when like those hoverboard Segway things were blowing up, and then so were the Samsung phones. That's a big problem because that's a lithium fire because it's lithium ion batteries. So if you try to put it out with water, you just make it worse. I think that's why like with electrical fires, you just do not use water.
Yep.
You got to use a official fire extinguisher. Yeah. So it's also interesting, you've got sodium. Sodium chloride is table salt.
Yeah.
So also,
If you watched Jimmy Neutron, you would know this.
yeah, if you watched Jimmy Neutron. Also, yeah, you have sodium and potassium. They seem to have weird symbols. It's like, why are these their symbols? And the reasoning is, sodium's real name in Latin is natrium, and potassium's real name is kalium.
Ooh.
But in English, we just decided, it's going to be sodium and potassium. So, but we left the symbols because standardization, So that's why, to every chemistry student's detriment, you have to memorize that K means potassium for no other reason than something in Latin. But if you take Latin too, then I think you're set. I think that's the Trinity. Like that's when you win. So those are alkali metals. You've also got francium, which is very radioactive. Just like radon, we don't really have enough of it to actually try out putting francium in water. But basically lithium fizzles and pops a little bit. Sodium will actually catch on fire and stuff in water. Potassium will do a big explosion.
Sodium's the cool
Basically, things just get worse and worse the farther down you go. They get more reactive the heavier the alkali metal. So if you gathered up enough francium to do some francium reaction, you would get scary results. I can say that much. It would not be good. The francium reactions would be violent.
You sound like an alien coming down to Earth to warn the humans.
About francium?
Is that, wait, hang on, Sebastian, is that a fact?
No, but now that you say it, I do have some interesting sodium facts.
Uh-huh.
Do you now?
I do. Sir Humphrey Davy discovered sodium only a few days after he discovered potassium.
Huh.
Oh, what a nerd.
Yeah, that would make sense, actually, because...
Maybe we should invite him on this podcast, huh?
We should.
This is actually an interesting thing. Basically, some of the elements in the same group, especially the lanthanides and actinides, they are so similar to each other that scientists actually had a difficult time discovering them because they were just too similar and they couldn't isolate them. That's for the actinides, I think, or the lanthanides. So I guess a similar thing must have happened here, and he separated potassium and then realized, oh wait, there's also this other thing that acts very similar to potassium, but it's not potassium, and that's sodium.
Sodium also comprises around 2.6% of the Earth's crust. So much like you, viewer, the Earth is salty.
Very true. The Earth is salty. I think that's a good place to go to the next slide.
I think it is.
Yes.
All right. So,
beryllium.
We have the alkaline earth metals, which are basically just...
Sorry, I got scared by the skeleton.
Yeah.
Oh,
they
yes.
include
so
calcium.
Here I've put in a, and yes, it's pronounced GIF.
Oh, yes.
Of
it's a GIF.
Skeleton giving the classic doot.
Yeah, the classic doot. It's Halloween.
A reference to upcoming event of Halloween.
Yeah. 5 days till Halloween. So thought we'd throw that in there,
Wait,
right?
is that true? Is it 5 days until Halloween?
Yep, today is
Yes.
October 26th. Yeah. So
Uh-oh.
these are the alkaline earth metals, right? They basically have similar properties to the alkali metals, but they're just like less intense. They're just like they're a little toned down, a little more mainstream, right? Basically, they have 2 electrons more than a complete shell. So their reactions are less violent because although they want to get rid of those 2 electrons, they've also completed a subshell. So they aren't like they're not like, it's weird. It's like they don't want to get rid of it that much, because basically they would be the most stable if they just had a complete like energy level. But if you can't have a complete energy level, it's like at least you can have a complete subshell, right? So they have a complete subshell. So they're kind of happy. But if they can get rid of the 2 electrons, they will. It's just they aren't going to have as much of a violent reaction,
Yes.
Basically, the point is that you can actually use beryllium and magnesium, for example, as like metals. Like they're actually like hard, like they're sturdy metals that you could use to, say, build a car, right? If you were to try to build a car out of lithium or sodium, it would just die the first time it rained, like the car would just erupt into flames pretty much. It would, and it's so soft that like, a dent would just total the car, right? But beryllium and magnesium you can actually use as metals. And so the reason that you would even want to use beryllium and magnesium as metals is that they are extremely light metals. They are the lightest 2 metals that you can use because of sodium and lithium being unusable. So beryllium's pretty expensive though. So for mainstream purposes, magnesium is your standard light metal. Magnesiim is.
You want to know an interesting fact about beryllium?
Sure.
I would love to hear.
Here you go. All right, here you go. Too much exposure to beryllium can actually cause a lung disease called berylliosis. And that's not made up.
That's true. The powder, right? The beryllium powder, I believe.
Yes.
Yeah, that's a problem.
It's also known as chronic beryllium disease, or CBD.
Wait, isn't there? Okay. Yeah,
creative names.
That's interesting. Anyways, so that's beryllium, right? And so magnesium is used more often. Beryllium is used when you really, really need a light metal, and like you can shell out. Like a lot of like research labs use it. If they're highly funded, they can be like, we're going to get that primo beryllium, we're going to use it for our experiments. But like, I don't know a lot like specifically, but do they use magnesium in cars? I don't know. I think, aircraft, this is actually in the next group. They use aluminium for all our British viewers, which is one heavier than magnesium. So it's still pretty light. But it's still pretty light, and they use aluminium in airplanes. So yeah.
Yep. So I
think we should take a minute. I think we should take a minute and address chat because we've had a few messages since we last.
Okay, the chat.
Okay. Be careful which one you read off.
Yeah. So from Johan at 7:32, we have I joined to find Brendan screaming.
Okay.
I read that and I turned my input volume down.
Mm-hmm.
Then Johan inhales xenon.
Mm-hmm.
Gravity
we just
Max
told you not
that.
to.
We do not promote this.
But I do.
Youie Films
and then the Lesbro says I can
barley
read. I can barely read, but I'll still read your book.
Thank you for reading the book.
That's something. We need to support the book.
Thank you. Johan says, "Hey, I'm not salty. Don't make assumptions on my personality." And the Lesbros seems to be disappointed by our attack on her English.
We apologize.
Hoo boy.
We apologize.
Back to your
Anyways,
regularly scheduled
to
program.
Okay.
Here's an interesting fact about magnesium.
Mm-hmm.
I actually have a couple of them.
Okay.
So magnesium gets its name from the district of Magnesia, which is in Greece, and that's where the compound was initially found. It was found in its form of magnesium carbonate. For many years, magnesium was thought to be the same element as calcium. And magnesium is sometimes used to help shorten the length of migraine headaches.
Oh, yeah, that's called milk of magnesia, I believe.
I believe it is.
It's like this
magnesium
medicine.
milk.
I think they, because it was like white. I mean, calcium is milk, so it's like they're similar in properties, which is why it was hard to like separate them, I guess. But yeah, I'm not sure how much it's used as a medicine now, but it was definitely like in the past, it was used a lot more as a medicine. I think they've got, I don't know, some more effective. I mean, I'm not like an expert on curing migraines, but you know, but yeah,
Really?
it was used for that. So that's pretty interesting.
That's pretty interesting.
Yeah. So then,
know that. Next time I have a migraine, I'll just eat some magnesium.
Nice. Okay. We do not support eating magnesium either. Do not bite down on just a chunk of magnesium because unlike the alkali metals, it is not soft enough to be cut through with a knife. So do not. You'll just break your teeth. But yeah, so then you've got calcium. Calcium's fun.
Calcium.
It's
in
your bones.
A main
most
part
notably,
of your skeleton.
Most notable for skeleton.
Yeah.
Yeah. Which is why we have our little doot, as it is said. Our little doot GIF.
Mm-hmm.
Yes, it's pronounced GIF. Up there in the corner of it. Calcium is necessary for life. Again, calcium is one of the elements in organic chemistry.
Yep, that's a slide.
So very important in biology.
Mm-hmm.
But calcium is actually a very important element in the construction of coral reefs. You've often heard that coral reefs are alive, and calcium is a large part of that.
Yeah. And
so the amount of calcium in the body can actually affect the rate that the heart beats.
Oh, that's
true. Vitamin D is necessary for our bodies to absorb calcium.
Yeah, actually, I believe like calcium and potassium, I think, are responsible for the ability to contract and extend one's muscles. When you want to contract a muscle, your brain sends a ton of potassium into that muscle, and when it expands, I think it sends calcium. I'm not sure exactly, but it's something like that.
And look at this! Look at this! You'll never guess who discovered calcium.
Who discovered calcium?
It was Sir Humphrey Davy.
Whoa!
Wow.
Yeah.
What a nerd.
He discovered
both. What a twist.
Wow. That's crazy.
Dude,
can we address chat really quickly? Can we address chat? Because there's a pretty good pun that was made.
Oh, okay.
And it's from Daniel the Manual. And says, really, they don't help my grains, maybe your grains.
Let's give him a round of applause, guys.
Wow.
And Barry Rudin is in chat, and she says, very interesting stuff, guys.
Yeah. Yeah. You might notice
all right, let's
same
move on.
Name as me.
Or are we still talking about calcium?
Yeah, we're still talking.
Calcium is just a very important element in organic chemistry. Mm-hmm. Calcium, you'll find it in your yogurt, you'll find it in your milk, you'll find it in your cheese. Other sources include salmon and tofu.
Mm. And just, I presume, the ground, too. It's a common element in the Earth's crust, right?
Yeah, I think it is.
Yeah. Oh, and also another interesting thing about calcium is that since it's an alkaline earth metal, right? So like sea animals that like shellfish, right? They use calcium in their shells, and it's actually a problem for them because of like ocean acidification, as like carbon dioxide gets dissolved into ocean water, it actually creates a more acidic solution, and this acidic solution actually breaks down the calcium in their shells, which, you know, it's not good when you live in a shell to have your shell dissolved. So there are fears that this could cause damage to the ocean ecosystem. So
That sounds very not good.
yeah, it's very not good. Generally not good.
I wonder if this is that happening at a fast or slow enough rate that natural selection would be able to correct it? Or is it happening faster than natural selection would be able to keep up with?
I am not sure. I mean, generally, things that humans do,
Usually faster, I would say.
it's usually faster. Because humanity, like, when you think of geological timescales compared to human timescales, there's just like it's just insanely off. But if they could evolve, it would be interesting. Because would you see calcium is element number 20, right? So element number 22 is titanium, so which is another metal. So I wonder if you would end up finding like sea life that have like transition metals in their shells, and they're just like shiny like metallic things, and it's like, what is this? It's like, yeah.
Well, here's an interesting fact, kind of related to the question that Brendan just posed. Around Chernobyl, after the reactor burst, and we're going to talk about nuclear reactors later on.
Yeah.
After the initial like explosion and like all the radiation and all that fallout that happened, a couple of decades after the initial explosion, a very specific type of mushrooms started appearing around the site that actually fed off the radiation.
Wow.
Yeah.
The energy,
It's pretty interesting.
That's really interesting. Yeah, I think we should go to the next slide soon. But basically, strontium, barium, and radium, they're just similar to these elements, but heavier. I don't know a whole lot about them, but, you know, I mean, presumably they do stuff.
I didn't even know strontium was a thing.
Yeah. They're in the same group. So I'm going to go to the next slide. This is
We're on number
our
5.
boron group. So boron is another element. And basically these elements have 3 more electrons than they need, which is like, it's 3 more electrons than having just a complete shell. But they're also close to that subshell range. They're 1 away from that subshell range. So they're a little wishy-washy on like what they do. They're just a little like, they are not highly reactive. I mean, you have aluminum, aluminium. I don't know which to say. Aluminum's quicker to say, though. Aluminum's quicker to say. But the scientific community widely uses aluminium. So it's actually interesting. I saw this video by...
Do you know who you're talking to?
I'm a
celebrity.
I saw this video.
I'm a YouTube famous celebrity.
I saw this video.
And I say it's aluminum.
No, okay. You see, I saw this video by this YouTube channel called the Periodic Table of Videos, right? And so they said that both are technically, like, both are used. It's okay to use both. But when publishing your scientific study on, like, the pages, like the forum, like there's this huge forum where all the studies are published. Oftentimes a scientist will look up aluminium, like Control F, look up aluminium to find studies involving aluminium. But if you use the word aluminum instead of aluminium in your study, they won't find your study, which is a problem because I think aluminum is only an American spelling, and I think the British spelling aluminium is probably used everywhere else. I think it's like a metric system type thing,
Yeah.
So if you want to have like, if you want to be scrupulous, if you want to like be serious in the scientific community, you should use aluminium. That's just a pro tip. Say aluminium instead of aluminum.
Here's an interesting fact about aluminum or aluminium.
Yeah. We can just say aluminum because we are Yankees.
And,
so
yeah. So aluminum is 100% recyclable and maintains the same physical properties after recycling as the original aluminum.
Yeah, that's actually true.
So that's why you have to remember the 3 R's. Reduce, reuse, recycle.
Yeah, the thing is,
when was the last time you guys heard that one?
Like 5th grade, probably.
It's honestly been a while. I don't know why
yeah.
they stopped using that.
I have no idea either.
Now they use swipe right.
So when aluminum reacts with hydrochloric acid,
Uh-huh.
it produces hydrogen gas.
So that's nice. You get
And in the mid 1800s, aluminum was more expensive than gold.
Yeah, that's true. It is hard to basically, if you have aluminum pots or pans, they want you to recycle those because it is a lot harder to mine aluminum than it is to just recycle it. So people are like, we should just recycle it. It's kind of stupid not to. So yeah, that's aluminum. These elements, they're kind of like tepid, you know. They don't have many violent reactions. But so another one is gallium. Gallium is really famous because gallium has a
very low melting point.
Yeah, its melting point.
Ooh, yeah. I forgot why I remembered this one.
Yeah, gallium's melting point is about that of human body temperature. Maybe a little more, maybe a little less.
It's 30 degrees Celsius, 85.5 degrees Fahrenheit.
So it's a little less than human body temperature. So if you have a nice solid piece of gallium and then you just grab it and you hold it in your hands for a few minutes, it'll just melt in your hands, and then you have this liquid metal in your hands, and I think it's probably won't kill you like mercury.
It doesn't.
Yeah, so
as far as we know.
Still don't eat it though. Like, don't inhale it. Just please, people, stop trying to misuse the elements. Just let them be. Okay? Yeah, that's my PSA.
Here's an interesting fact about gallium.
Uh-huh.
Ooh, let's hear it.
Don't eat gallium.
Yeah.
Gallium-based solar panels are actually used to provide power for space applications like satellites and the Mars rover missions. So it was gallium that failed Opportunity.
Oh, really? Oh, yeah. Well, indirectly, yes. I have a question.
Indirectly.
Is the gallium tied up in compounds? Because I'd imagine you wouldn't want your solar sails to just melt.
Yes. Yeah, no.
Yeah.
It is.
Yeah.
I could get that.
I
for
see an
you.
issue.
Oh, I think I know.
I see a potential issue with a gallium solar cell.
Yeah. I made a video about how solar panels worked in the past, and it's basically like you have your P-type and N-type layers. You can go watch that video. I don't want to say the whole spiel again of this 5-minute video I made, but basically, yeah, it's used in low concentrations along with other materials. So, yeah, so you've got those. Then you also have nihonium, which is one of our newer elements. I like its name. I like saying it, nihonium. I don't know why. It just sounds nice.
Is that related to Japan in any way?
I have no idea.
I'm just saying that because Nihon is just Japan and Japanese.
Is it?
I actually think I remember one of the newer elements was discovered in a Japanese lab.
Yeah, it is. So. It's named after Japan. Or Nihonium.
So,
Japanese.
Fun fact.
That's very interesting.
Japanium.
I had no idea that was
nihonium.
A thing.
That's cool. That's really interesting. That's great. Yeah, the newer elements are all named after places. Like you have, there are 3 elements. I think maybe 4. I'm not sure about the 4th one, but there's at least 3 that are all named after labs at Berkeley College. There's berkelium, then there's lawrencium, and there's livermorium. Now, berkelium is for Berkeley, and then there's a lab at Berkeley called the Lawrence Livermore Labs because those are 2 scientists that were involved there. So you have lawrencium and livermorium. And then there's also californium. So, yeah, that's interesting.
Wait, what's californium named for?
California.
Mexico?
Oh, okay.
I mean, it was a Mexican state in the 1800s, so.
It was.
Oh, that's true. It is true.
Yeah. So I guess we'll go to the next slide.
Let's do it.
Cool.
Hey, wait. Before we do that.
Oh, yeah?
Once again, we have a second pun in chat.
Oh, no.
Ooh, let's hear it.
Coming from Johan. 754. This section doesn't have my attention. It's pretty boron. Gotta say, pretty. No applause. Pretty weak.
Sorry, let me retract my applause. I think that was a good pun.
I
Yeah.
think that's pretty bad. It's too basic, you know? Because when
Let's
the
have a debate.
slide first
Let's have
came
a
on,
debate.
when the slide first came on, I was like, oh, I could probably try to work in a pun of like, oh, boron sounds like boring. But I was like, hey, I don't really want to interrupt the flow, you know? But yeah, I think it's just too basic. It's too low hanging. It really doesn't go as deep as really they don't help migraines, maybe your grains.
You know, I think maybe you're just upset that you didn't get to say the pun.
Oh, that's what it is. Anywho's, on to carbon.
Yeah, onto carbon. So this is
Carbon.
the carbon group.
This is what makes you, me, diamonds, and coal. This is
Diamonds.
very important.
Mhm.
Definitely one of the largest organic elements in organic chemistry.
Yeah.
You'll hear often that humans are carbon-based life forms. This is true.
Yeah. Everything
because,
that we know of.
going back to the
all
nucleic
life,
acids,
yeah.
carbon is heavily involved in making bonds.
Yeah, and basically, I'll explain the reason. So, the reason that carbon is used, like everything's carbon based, is because carbon has 4 more electrons than a complete electron shell, but it also has 4 less electrons than a complete electron shell. So it's exactly in the middle, which might make you think like, oh, it's probably really unstable, but its reactions aren't that violent. It is unstable in the fact that you won't just find lone carbon atoms. You can have pure carbon substances, which is just carbon bonded to carbon, but basically the point is carbon likes to make 4 bonds to either complete or empty its shell. And that's its modus operandi. That's just what carbon does. It makes a ton of bonds, which allows you to have these complex molecular structures because if you could only make 2 or 3 bonds, right, then you couldn't have something like DNA, which like goes on, it stretches on, it's a huge polymer, right? Polymers, you can make them with elements that only make less bonds, but carbon is super useful because it can make so many bonds, so you can have very complex polymers with carbon. And that's just how life works. You've got these crazy enzymes and stuff that are folded into like weird shapes, and like the body is able to make so many different ones. And it's all because of carbon. Yeah, carbon. Shout out to carbon. Yeah.
My man's carbon.
Carbon's really useful.
None of us would be here
Mm-hmm.
without it.
Yep.
I'm a fan of it. I
Yeah.
like it.
Mm-hmm.
Some don't. I'm a fan of it.
How do you not like carbon?
Yeah, how can you not like carbon?
Man, there are just some people out there that will hate on anything.
Bro, people
That's-
really be wild. Man,
That's
you know
too
what I'm
true.
saying?
That's too
No,
true.
like, they just not vibing with the carbon. That's what I'm saying. You
Yeah.
know what I'm saying?
Yo, vibe. You ever do a vibe check with carbon?
Oh no.
If I was gonna do a vibe check on carbon, I don't know what I would find other than its atomic weight is 12.011. It's classified as a non-metal. It's
Mhm.
solid at room temperature.
Are you just
Its
reading the
melting
Wikipedia
point
page?
is 3,550 degrees Celsius. Its boiling point is 4,200 degrees Celsius.
Jesus.
Okay.
That's like, what was
And
that boiling point?
its sublimation point is 3,642 degrees Celsius.
Nice
And
job.
carbon has been known about since ancient times.
Cool.
All right, I'm gonna have to interrupt again with a question from chat.
Oh,
Oh,
question.
let me hear it.
We will answer the question.
Barry Rudin, what are your favorite enzymes?
My
My
favorite enzymes.
Okay.
I
Let's see.
am personally, I'm impartial to the stomach enzymes because I'm
stomach
a very like the digestive enzymes in the
Mhm.
stomach.
Yep.
Yeah,
Such
you've
as
been putting on
pepsin.
some weight recently, actually.
Oh, thank you. That's hurtful. Like pepsin and mostly pepsin. Pepsin allows me to eat whatever I want. I have a very fast metabolism due to my age, and it allows me to eat everything and anything without gaining that much weight. Although this is
As a man,
contrast
yep.
to what Brendan is saying because he thinks I've been putting on weight. When actually, contrary to that, I lost 7 pounds last year.
Nice
As a
job.
man of also a fast metabolism,
Mhm.
I can agree with everything you just said, as I also lost 6 pounds in the last year.
Okay. Well, I am a fan of insulin because it allows me to.
Wow.
Well,
Way to be special.
okay, because it allows me
different.
to, not have like diabetes and issues like that. It allows me to digest glucose, which is sugar, and I like dessert. So also,
Oh, he's a man partial to the dessert.
yeah. Also, another
Dessert.
good enzyme is hemoglobin.
You like
That's
eating
that's
sand?
that's
You
another
like eating
fun
desert?
enzyme. Stop. No.
Where are you going with this?
Hemoglobin.
I don't know. We can go somewhere by going to chat again with also, do you three have any thoughts on reducing carbon footprints based on what you know about carbons?
Oh, who asked that?
I feel like that's something we could save for an entire show.
Probably,
Yes.
actually. We had that in the woodworks. We could talk about that another time, I
So
think.
you'll have to tune in at 7 on Saturdays every week.
Yeah.
7 p.m. EST every
Eastern Standard
Saturday.
Time. Yeah. So back to the carbon group, right?
Yes.
So the next lightest element in the carbon group is silicon. Now, ideas have floated around in like sci-fi and stuff about silicon-based life because since silicon is also in the carbon group, it can also make 4 bonds. So people have speculated, could you just substitute carbon for silicon in certain enzymes and just, create an ecology off of that? Now, it really isn't as simple as that. And the reason is silicon has a higher atomic number, so a higher atomic mass as well, which means that in chemical reactions, it'll take more energy to be compelled to like react. So things will happen at different temperatures, and it won't be just a uniform raise in temperature. So you can't just have like the hot planet be silicon-based life. It'll be all over the place. Things will be vastly changed, and it might not really work. So that's silicon-based life. Then you also have Silicon Valley, which is this in California, this technological like computer science center, and like the center of industry there, right? And so basically, Silicon Valley is called that because computers use silicon because of its properties of semiconducting, which allow computers to work.
Yes.
Yeah.
Yep.
Sorry, I was muted. I was
Okay.
making sure.
I was getting a little worried actually near the end there.
Yeah.
Because things were eerily
Sorry.
silent, and
I
I
don't-
was like, please don't say like the stream fell through or like my Wi-Fi just shut down.
Yeah.
I was like, please.
So
Sorry, I opened up
here's
Reddit
some.
for a quick second, and I
Okay.
found just a random fact.
Mhm.
Oh,
I
yeah,
actually
go ahead.
already knew this, but it reminded me of it.
Mhm.
Do you guys know the door to hell?
I do not.
Like in
So in
yeah.
In
Go ahead.
1971, Soviet engineers working in Turkmenistan set a hole on
Turkmenistan.
fire. Set a hole on fire which was filled with natural gases.
Mhm.
They expected the flames inside to burn for a few days. However,
Mhm.
they soon found out this would not be the case.
Uh-oh.
The hole has been burning for over 46 years and is known as the door to hell.
Oh my
Wow.
gosh.
That reminds me of
Classic
like Silent Hill, where the town
classic
is like always
oversight,
on fire.
common mistake,
Yeah.
rookie error. Well, that's not good, but yeah. So your other carbon
Let's
group
move
elements.
back to the slides.
So yeah,
Yeah,
my,
so you
my
have-
interesting fact about
Oh,
silicon.
yeah, okay.
If you want to hear it.
Yeah, sure.
Let's
Here we
hear
go.
it.
The most abundant compound
Hmm.
in the Earth's crust is silicon dioxide.
Yep.
And silicon has the relatively unique property for an element in that it expands when it freezes, much like how water does.
That's interesting.
That's pretty cool.
Yeah.
Silicon carbide
Hmm.
is often used as an abrasive and is nearly as hard as diamond.
Interesting.
The name silicon comes from the Latin word silicus, which means flint, and flint is a material that contains silicon.
Wow.
Doesn't know. I actually
Enlightening
did not
us.
know that one.
But yeah, silicon
does.
is actually really important. You might have heard of the word silicate, which is like a material that stuff in space can be made out of, like asteroids can be known as silicate asteroids. And these are just silicon compounds. Silicon is very important. Maybe not for life, but definitely for computer science and for materials in space. So yeah, so that's silicon. Then you have germanium, named after the country of France. Just kidding. It's Germany. It's named after. Yeah.
Sorry, if I were to talk, I just wanted to comment on the whole silicon being used in space thing.
Yeah.
If you do want to learn about space and you're just tuning in, there is a book being released soon called A Truly Dead Rock.
Yep.
And you can get it off of Amazon.
Yeah.
I think it's going to be released around Thanksgiving time. So
Yep.
make sure.
That's what I've heard.
Yeah.
I've heard it.
Rumor has
and boy,
it.
am I excited.
Cool. So yeah. So
All right.
germanium is also used in computer science, along with silicon. There's like germanium like crystal plates that are used sometimes. Then you have tin, like tin cans. Yeah, that's all I have to say about tin.
Right.
Then you have, tin is tin. Like everyone knows tin. So then you've got lead, which is it's actually a very interesting element. Lead is the last element that has stable isotopes. Everything else is radioactive.
Yes, it is.
So lead it's also not good for the human body, especially when it contaminates water. There's like, they used to use, I think, lead pipes in like Rome. Didn't end well.
Ooh. Touchy subject.
Yeah, touchy subject.
Touchy subject in a certain town in Michigan.
Yeah, there recently. I mean, it's been going for a few years. I really don't know why they haven't.
Yeah, they
dealt
still
with
don't
it
have
yet.
water.
How does it's really weird? How do they just not have water for 4 years and no one
learned is that if you compare charts of lead levels in adolescence and you overlay them with violence levels in adolescence, it almost perfectly correlates.
Wow.
So lead
Fun
causes
little
violence.
fact.
Maybe that's the answer. It's not video games. Okay.
It's lead.
It's lead.
It's lead. And that's why there are there's really high violence when leaded gasoline was huge.
Yeah.
That did actually
Leaded
contribute to violence levels.
Yeah, I watched this documentary about this guy who was like, hey, stop putting lead in gasoline. And then the companies were like, no. And then eventually they stopped. And it's really weird because if you go to a gas station today, you'll notice that they say unleaded. And it's like, yeah, I sure hope so.
Yeah.
It's been unleaded for like 50 years.
I sure
we get
hope
it.
It does.
Like we don't need that constant reminder that you're unleaded. Like we get it. Like been there, done
we
that.
We don't do that here.
But here's an interesting fact about lead.
Yeah. Go ahead.
Here you go. So alchemists were like the first chemists, some would say, and they famously tried to turn lead into gold, right?
Ha.
Or copper into gold, or pretty much anything into gold. They really liked gold.
They just like gold.
They were big fans of gold.
Yeah.
Yeah, they liked it. Alchemists had symbols, much like we do on the periodic table, but they had actual like hand-drawn symbols, and they would associate elements with other aspects of life. Lead was associated with the planet Saturn.
That's very random, but interesting.
It is.
Why is that?
I could not tell you.
They just chose it.
Right.
It is because lead, if you hold a brick of lead, it's going to be heavy.
Okay.
And the planet Saturn is also heavy.
The planet Saturn weighs at least one lead brick.
That's true.
Yes.
Oh yeah. Anyways, also lead is useful for radioactive shielding. So if you go to get an X-ray, sometimes they'll put a lead like apron on you to protect your body from the dangerous X-rays, other than the area that they're trying to X-ray. Like I had braces, like I used to have braces, and like they needed to do like tooth X-rays, like jaw X-rays. So then they like did that, and I wore like a lead thing. Yeah.
Yeah, you
So
have to bite down on like this
yeah,
lead-looking square,
yeah,
and like it
yeah.
cuts
It's
into the
weird.
top and bottom of
Yeah,
your mouth, and they're
yeah,
like, bite down harder,
yeah,
and you're like,
yeah,
I don't want to.
yeah. Exactly. Yeah. So the next one, I'm gonna try to speed up a little bit here. Is
Yeah.
All
fluorovium.
right.
Fluorovium is the only element out of the 6 newest ones that has actually been identified as as part of a group. They can identify its properties better. I think it's because it's like in an island of stability or something. I don't really get it, but it's a post-transition metal like tin and lead. So I'm gonna move on to the nitrogen.
Very cool.
Yeah.
Nitrogen.
All right.
That's a pretty common one in the
Nitrogen.
human body, is
Yeah.
it not?
Nitrogen. So the nitrogen
Our
group.
air is around like a lot percent
Yeah,
nitrogen.
it's
like
78%.
78%.
Yeah. So the nitrogen group is also known as the pnictogens. Pnictogens. I really don't know. It's kind of weird. I don't know why it's
Yeah.
called that. I'm just gonna say the nitrogen group just because it sounds better. So
All right.
nitrogen, very common in the air, and the thing about nitrogen is that it can make 3 bonds, right? So because it's 3 electrons away from a complete shell. Now this is really interesting. The way that molecular geometry works makes quadruple bonds impossible. So you would think that like carbon would have the strongest bonds because it could make quadruple bonds, but it can't. So instead, nitrogen, which can make triple bonds, has the strongest bonds, and it's actually really hard to pull apart nitrogen. Like, you can burn most diatomic atoms, such as hydrogen, I think fluorine, but nitrogen does not burn. That's interesting because whenever chemists are doing a reaction and they just really don't want it to like set on fire, they just kind of dump some nitrogen on there to keep it from combusting with the air, you know.
All right.
Yeah. So
yeah, nitrogen is again one of the organic, one of the main players in the organic chemistry. It's used in the nucleic acids, and it obviously allows life on Earth to occur because it makes up such a large part of Earth's atmosphere. Nitrogen is one of the things that NASA and other space, well, right now it's only NASA, what NASA looks for when searching for planets that can have life, that can support life. Nitrogen is one of the key things they look for.
Yeah, that's true. Because if you consider the biogeochemical cycles of the Earth,
that's a big word.
If you recall from biology last year, nitrogen cycle was a thing because plants need it to make like organic molecules. So that's nitrogen. So then you've got phosphorus. It's used in matches because it burns well, I guess. I don't know a lot about phosphorus. Yeah. Then you've got arsenic.
Phosphorus.
Oh yeah.
Yeah, that's a.
Yeah, I don't know.
I used to know phosphorus. I know something about it, but I forget what it is.
Okay. So arsenic. So we'll come back to that, but so arsenic is the thing that I think in an episode of Friends, I think someone just got killed from ingesting too much arsenic because it was used in a glue for like letters. So like, you know how you have to like lick the envelope to get it to seal?
Yeah.
Envelopes actually contain very small amounts of arsenic, which it's okay if you're just gonna like send a few letters, but there was like they were sending out letters for like a wedding and they were inviting a lot of people, and then so she was like making all these envelopes, and then she just like died from arsenic poisoning. I don't think it could really happen in real life, but it happened in the TV show.
Envelopes.
What? Anyways,
I was gonna go get a settlement from Staples,
okay.
the supply store.
Yeah. Anyways, yeah. So arsenic, we do not
Yep.
condone the ingestion of arsenic.
I do
Please
not
don't
condone
eat.
the
We'll throw
do
that
not
on the
eat
list
arsenic.
of please don't.
You can inhale nitrogen if you want. I give you full permission to inhale nitrogen, but just
Yes.
not arsenic. So yeah. Then you've got.
Make sure you put some oxygen in the nitrogen, though.
Oh yeah, make sure you put some oxygen in there. Yeah. So then you've got
Okay,
antimony.
well, here's an interesting fact
Mhm.
about arsenic.
Yes.
on the fact site that I'm on,
Mm-hmm.
in a subnote, it says, "We recommend that you, in all caps, never use, handle, or experiment with arsenic or its compounds. It is very dangerous."
Words of the wise, honestly.
Yeah, so
Yeah.
I want to take that same disclaimer and throw it up on this live stream.
Yep. Great disclaimer.
So, yeah.
Yeah.
So
then you have
anyways.
antimony. Just gonna brush by
Yeah.
that. Then you have bismuth, which is really interesting. I'm not sure of its uses, but I know that it has a really interesting looking crystal. The crystalline form of bismuth is like really weird. It looks like rainbowy, and it's just kind of weird. So yeah, there's bismuth. And then you have moscovium, which is the newest element, named after a particular city in Russia. You might guess which one. Moscow. So its properties haven't been...
Really?
Yeah. It's actually
That's
Stalingrad.
crazy.
Named after Stalingrad, not Moscow. No, just. Yeah. Honestly, I'm just going to make a misnaming joke for each of these, but no. So, moscovium has not had its properties determined yet, unlike fluorovium. So, that's the nitrogen group. We'll come back to it for organic chemistry a little later.
Moving on.
So now,
oxygen.
Oxygen. Also
Are we
known as
moving
the chalcogen.
Oxygen. This
something
one's
like
not
that.
too important.
Oxygen. Yeah, we can just skip this slide on. No, just kidding. Oxygen is how we maintain homeostasis. It's very important as an energy source for life because we use it to the reason we breathe in oxygen is to break it down along with sugars and stuff like that and various other molecules that we eat, and then it makes energy in the form of ATP, which is adenosine triphosphate, which is a use of phosphorus. We'll see that later, but so yeah, oxygen, very common in the air, but also it's like a very reactive element. People don't realize it that much. People just see oxygen as like the life giver, but oxygen can be seriously deadly. For example, if you were a metallic building, you would not be very happy with oxygen because oxygen causes rust. And it's interesting because a similar thing to rust kind of happens in your body on a slower pace. And one of the theories
okay,
of...
hang on.
Yeah.
What? Could you expand on the whole your body rusting?
Yeah,
thing?
okay. One of the theories of aging is basically that as you get older, your mitochondria, the powerhouses of the cell, they begin breaking down, and they just don't really know what they're doing. So then they start producing harmful waste products, which are oxygen ions called free radicals. So these are oxygen ions that are not bounded up in a compound, which oxygen, in the oxygen group, they are only missing 2 electrons from completing a shell. So they really want to complete that shell. And so these free radical oxygen ions just go around your body wreaking havoc and causing more mitochondria to start doing the same. And that's a theory of aging, and that it just messes up your body and its systems. There's actually a condition known as hyperoxemia, which is the reason that they even want to dilute oxygen when a diver goes diving. Because if you were to breathe pure oxygen, it would not go well for you. You would just not do good.
You need the other stuff, right?
You don't need it at all. You really only need oxygen, but you need the other stuff to protect you from too much oxygen. That's really it. It's kind of ridiculous, but If oxygen were to double its content in the air, this is an interesting thing. It would make you live shorter, but while you were alive, it will increase your mental capacity and like strength and stuff like that because your body can use more of it for energy. But it's kind of like so it's kind of a double-edged sword, oxygen. You can use it for energy, but then it's also damaging to the body. So it's a really interesting element. It's the second most electronegative element, which you don't think about. After fluorine, it is the most electronegative element. So it really wants to gather electrons. It really wants to snatch electrons. And that's what it does in the universe, you know?
It's very good at what it does.
Yeah. Also, oxygen is the third most common compound, or the third most common element in the universe. So oxygen is the third most common element, which is interesting because it makes oxygen's compound with hydrogen the second most common compound in the universe because the first is diatomic hydrogen, and then you get oxygen and two hydrogens to form water. So people like to say like, oh, we need to find a planet with water, like water is so uncommon in the universe. It really isn't. It's like really common. So, yeah.
Well, actually, do we know how many planets, like, roughly we've found water on?
Like a lot. I think at least half of them. Like water is super common.
Really?
Yeah.
So, well, I guess there used to be water on Mars.
Yeah, exactly.
There's water on some of the moons.
Yeah. Basically, the basic issue is that oxygen's very volatile. Water's very volatile as a compound, so it gets blown away by radiation into the outer reaches of a solar system where it freezes into ice and can't be used for life. That's the issue, but just on the whole, it is super common. There is more water on, like, any of Jupiter's moons than there are on Earth. And those are tiny moons, too.
Well, that's because they have, like,
they're, like, made of ice.
4-mile water crust.
Yeah, exactly. So, yeah. So that's a lot about oxygen and stuff like that. So then you have sulfur, which is the rotten egg element. The one that people are like...
Okay, so we were doing a lab not yesterday, a few days ago, right? And we're boiling water and like finding how gases change size based on heat, right?
Yeah.
And on the table, there's a mysterious yellow powder.
Uh-oh. Yep, that's your sulfur.
And I guess someone spilled sulfur on our table and didn't clean it up.
That's not good.
But then I was distracted because someone dropped a beaker of boiling water.
Yeah, that would distract you.
It was not me. I did not drop
good.
it.
So here's an interesting fact about.
Yeah.
One of the moons of Jupiter, Io, appears yellow due to the large amount of sulfur on its surface.
Yeah, that's true.
The sulfur comes from the many active volcanoes on it.
Yeah. Sulfur is also very commonly used in organic chemistry because sulfur can make a lot of bonds. It's weird. Sulfur is only 2 away from completing a shell, but it's also 6 away from emptying a shell. So it can make 6 bonds, which is really weird. It's kind of like going backwards, but I'll talk about that a bit later. So then you have your other elements in the oxygen group: selenium, tellurium, polonium, and livermorium. And livermorium, again, one of the new elements, and that's the one I was talking about earlier.
Let me guess. Livermore.
Yeah, it's named after Livermore, Lawrence Livermore Labs, you know. So that's oxygen. That's the oxygen group. So I'm going to move on.
Yep.
So our next slide is the halogens. The halogens are 1 away from completing an electron shell. And these include fluorine, chlorine, bromine, iodine, acetine, and tennessine. You can see they have a nice naming system that's always ending in
I noticed a pattern with the naming.
Yeah. I honestly wish all the other elements had this instead of just being random.
It would be so much easier to remember.
Exactly, right? Like each element group should have, at least out of the main groups, they should have a set thing. The noble gases kind of had that with neon, argon, krypton, radon. They always had that on ending except for helium. But yeah,
helium should be, honestly, it should be helium.
like helium.
Elon?
Yeah,
helium.
Elon.
Elon Musk. Yeah,
Elon.
I actually purchased.
Elon Musk.
I purchased
is a
a
noble
biography about Elon Musk today at a bookstore. So I'm gonna read that. Anyways.
I also have that.
Oh really?
I've been meaning to read that.
Cool. So we have fluorine is the main element here, and it is the most electronegative element, and therefore it is the most reactive. It is just kind of crazy. Fluorine, it's like ridiculous stuff. You might know that they put fluoride in water to help your teeth, and here's a big distinction. Fluorine is just the element, but fluoride is fluorine with an extra electron, which just completes a shell and makes it super safe and like nothing you need to worry about. It's just a negative ion. Like, I don't know, I think there's probably conspiracy theories about fluoride from people that don't really understand science.
I don't like them putting chemicals in the water.
Yeah, like there's always a conspiracy theory. People that don't understand science just kind of get scared by things that sound bad. Like they like to use the fact that fluorine is a really dangerous element on its own to say that it's bad to have fluoride in the water, but fluoride is the ion. So yeah, it's just, it's
like saying that like there's this one artificial sweetener, I forget which one, and it's one molecule off of rat poison.
Oh yeah.
Like, okay.
Yeah.
I don't think it's gonna spontaneously react with something and every single molecule become rat poison.
Exactly. Yeah. Scientific literacy is a bit of a problem. Lack of scientific literacy, I should say. So yeah. Also, you might notice is that whenever you have a negative ion of a halogen, the ine changes to ide, which is where you get sodium chloride, because it's a negative chlorine ion along with a positive sodium ion. So they also use...
I have a bone to pick with chlorine.
Oh, you have a problem with chlorine?
It makes my skin itch when I swim.
Oh, yeah. You are on the water polo team, right?
Yes, I am.
So how's that? Like, what do you think about chlorine and how they use it in pools and stuff?
They chlorinate the pool every Monday. Mm-hmm. And I then have to immediately go take a 30-minute shower, or I will stay up for an hour not being able to go to sleep because my skin itches. Why does chlorine make your skin itch? Why is that a thing?
Here's an interesting fact about chlorine.
Well, I think
chlorine gas was used by the Germans in World War I as a weapon.
Yeah.
Well,
yeah, that's basically
the problem. So it
obviously
has properties that make the human body react in one way or the other to it. So I think that may explain it.
Yeah, that's the problem.
Chlorine is trying to poison us all.
Yeah, chlorine is pretty it's pretty like reactive. It's pretty dangerous. It is a poison as well. Yeah. It was it was used in World War I because of its atomic mass, the chlorine atom is heavier than air. So what would happen is it would float over to the other like nations' trenches and it would sink in, and then it would kill people until they started developing the masks for it. But chlorine, not good. Just these are dangerous. They tend to be dangerous.
Do not eat chlorine.
Yeah, do not eat chlorine. Do not drink the pool water.
I've drank a lot of chlorine. I have consumed many chlorines.
Yeah, but the reason they use chlorine...
it's not just straight chlorine.
Yeah.
And chlorine bad for you.
Yeah, the reason they use chlorine in pool water is to kill bacteria. And so basically the reason why it irritates the skin is that typically what happens is, this is a common thing that people do. There's something that's very harmful to bacteria and then only slightly harmful to humans, and we just throw it in there and kind of like deal with it. And we're just like, fine, we'll deal with this slight irritation as opposed to like bacterial infections. It's a bit of a trade-off, but yeah. So the next element is bromine. And bromine is one of the two liquid temperature or room temperature liquid elements along with mercury. Bromine is actually a liquid at room temperature. It's a red liquid, very strange. It's like a weird substance, but it's also pretty dangerous because that's just what these halogens are. So that's bromine.
Aren't like the bromine like an animal in some video game?
I'm not aware.
Sebastian, that would be directed at you. Yeah. What game is that? Like Fallout, Skyrim?
I cannot tell you. I don't think it's from Fallout. You're talking about the Brahmin?
The Brahmin, that's what it is.
Those are mutated cows. Nothing to do with the element.
From Fallout 4.
Wait,
Oh,
is
no,
that does that have to do with
element.
like, I don't know, isn't like Brahma or something? Like, is that what
Brahma?
it's named after? Yeah, I think that's a thing.
They have affiliation with the settlements
what's
and
a
the
Brahma?
caravan guards.
It's like it has to do with like Hindu mythology, I think. But anyways,
Oh, maybe.
Anyways, though, so the next one is iodine, which is actually used in like Pepto-Bismol to cure a stomach ache. So that's that's one you can eat, I guess. So then you have astatine,
but not too much.
Yeah, not too much. Only use medicine when it is necessary. Yeah, don't just eat medicine.
Yes.
Anyway, so then you've got astatine and tennessine. Tennessine is one of the new elements, and I am very grateful that they continued with the naming system. They named it after the U.S. state Tennessee, and so you've got tennessine, right? So I'm gonna
Couldn't tell.
Yeah, so I'm gonna go to the next slide. We have organic chemistry.
Right.
So here we have a few of the most common elements.
We are finally past the groups.
Yeah.
Sort of.
Sorry, this is going to be one of the longer streams.
We have a lot more to go.
This is going to be one of the longer streams. What?
When we start hitting like the other groups, it'll definitely pick up.
Yeah, that's true.
Yeah.
Anyways, so we have also if we want, we can take like a 5-minute break at some point in the future. So
actually, I kind of want to go get a drink. You guys want to take a quick 5-minute break now?
Sure, let's do a 5-minute break.
Those 9
groups.
Little coffee break.
Gravity Max will return.
Yeah, sure. Throw it on the title slide.
Okay. We'll be live shortly.
We will be back momentarily.
Okay. Yeah, we'll be back at like 8:42. Okay. Cool.
Yep.
All right, it's 8:42. Is everybody back? I guess
That is something that I am.
Yep.
Oh, okay.
I
cool.
am back.
Great. Okay.
For the future.
So we had a fun comment that was munch because I was eating a granola bar. Thank you, commenter.
How did he know?
I guess he heard me going munch. I think that's.
I did not hear any crunch on my end.
I think that's the assumption.
But that may have been because I was watching a YouTube video.
Oh, okay. Well, anyways, so after that,
I'm feeling very refreshed. I got my drinks.
Okay, cool. So after that brief interlude, let's take a look at some organic chemistry. So
Ooh.
basically, carbon, nitrogen, oxygen, and hydrogen. These are like your main. These four elements. They make up everything from caffeine to melatonin to adenine, guanine, cytosine, and the last one, thymine, I think, something like that, which are the four base pairs for DNA. Phosphorus is used in the helix part of the DNA, so the outside part, and it's also used for energy in the cells, which is adenosine triphosphate, which is like a tiny battery that our cells use.
ATP, the energy.
Yeah. So then you've got some alkali metals, alkaline earth metals that are used, as I said, for muscle contraction, but they're also used as electrolytes. They basically, like in water, water has minerals in it, and those are kind of these elements down at the bottom left. Because basically, you don't want to drink pure water. You don't want to drink like 100% H2O, because what'll happen is your cells, because of osmosis, it'll cause your cells, I believe, to overinflate and like burst and just die. But at the same time, you don't want to drink overly mineralized water, such as salt water, right? Like in the ocean. Well, first there's a sanitary concern, but you don't want to drink salt water because it'll actually drain water out of your cells and make them shrivel up and die. So that's kind of why you don't drink ocean water. Like when there's a shipwreck, right? And they're lost at sea, often they'll resort to drinking seawater just because they're like so thirsty and they're like, it's water. But then that actually makes them die quicker, which is, not fun.
So, the Gravity Max live stream does not support the consumption of salt water if you are shipwrecked. I
don't know why, but this is like, oh my gosh, we just need to constantly say, don't eat this stuff. You can, however, eat a Nature Valley Kirkland signature, I believe. Oh wait, no, it's Nature Valley protein bar. Gluten-free, 10 grams of protein, peanut butter and dark chocolate.
That's more than 5.
If you want a munch sound, yeah.
Well, I am going to I will counter your bar and raise you a pizza slice.
A pizza slice. Wow. I had pizza like yesterday.
It's a common food.
Yeah, pizza, very common food. Anyways, so
made up of hydrogen, carbon, nitrogen, and oxygen.
That's your organic chemistry. But yeah, so phosphorus and sulfur, they're used. Phosphorus can make 5 and sulfur can make 6 bonds by pretty much going backwards and emptying their shells instead of filling them, which is just kind of weird. But they do it. I don't know why.
So here's an interesting fact about phosphorus.
Mm-hmm.
Ooh, let's hear it.
You ready?
Yep.
I am ready.
So, I got a couple. Touching white phosphorus can cause severe burns.
Mm-hmm.
But black phosphorus, on the other hand, looks like graphite powder and conducts electricity even though it's not a metal. The majority of phosphate rock that is mined in the United States comes from Florida, and North Carolina.
That's interesting.
It is
God,
also
Florida
used
sucks.
in
Imagine
detergent.
living in Florida.
Yeah, I know.
I can't.
Yeah, I can't imagine living in
Can't
Florida.
even imagine.
Oh,
living
and
in
also
Florida.
phosphorus gets its name from the Greek word phosphoros,
Mhm.
meaning bringer of light. And the guy that found it, Hennig Brandt, he picked that name because the element glowed in the dark. Now, here's a little anecdote. Hennig Brandt was actually trying to find something else
Mhm.
and some other element, and the way he did it is that he boiled hundreds and hundreds of liters of his own urine, and that's how he discovered phosphorus.
I don't know what to say about this man.
Hennig Brandt.
So this is an experiment you can try at home.
Wizard.
No, don't do it.
Again, we recommend we not consume.
Yeah.
any of this.
Okay, Gravity Max does not recommend doing this experiment at home.
Mhm.
Youie
Actually,
Films
no. You can
completely
eat
recommends-
phosphorus. You can eat it. It's in beans, nuts, eggs, fish, milk, and chicken. I thought that said children. I kid you not. When I was looking at
Oh
that
my
list, I thought
God.
it was beans, nuts, eggs, fish, milk, and children.
Oh no. Well,
Gravity Max does not.
We
support
do not
eating
condone
children.
yeah.
the consummation of children.
Yeah. So there's your organic chemistry.
Although they are rich in phosphorus.
No.
Uh-oh.
So here we have the metalloids as our next slide. What?
What?
We just transitioned right after that.
Yeah, well, I was trying to say we're done with organic chemistry, so here we have our metalloids. So metalloids have some of the properties of metals and some of the properties of nonmetals, hence the name metalloids. Yeah? So, yeah, it's all coming together, right? So metalloids,
Yes.
they basically kind of conduct electricity and kind of don't. Whereas metals conduct electricity better and non-metals just really do not. Your metalloids are semiconductors, which are useful in, as I said, computers, Silicon Valley. That's silicon and germanium are mainly used, but boron, arsenic, antimony, tellurium, and astatine are also considered to have these properties. And I don't know if they are, but I believe they can be used occasionally in computers, but I think silicon is really mainly used both because of its commonality in the Earth's crust, so it's like cheap to get, and because it's the best of the metalloids. It's the one that works the best.
Silicon is used in a lot of computer chips.
Yeah.
It's actually used pretty much everywhere. Computers.
Mhm.
It's used in semiconductor chips, which go in computers, televisions, video game consoles, mobile phones. It's also used in a bunch of metal alloys, like with aluminum, iron, and steel. What's up? What's the no?
So I'm gonna have to draw your attention to chat.
Oh gosh.
To chat.
To chat. Here, wait. Let's
From
see.
Sebastian Molino, Crunchy Children.
Oh no.
From J.L. McCarthy, Crunchy Children. From Youie Films, I'm calling child services. From John McCarthy, child services can't protect them when they don't know where they are.
Oh my gosh.
Okay, anyways, germanium has a very interesting melting of 938 degrees Celsius.
So that's a pretty high melting point.
And an interesting fact about germanium is commonly used as a distraction to make sure that people don't think that this is a child murdering stream. But also Dmitry Mendeleev, the creator of the periodic table, first named this element ecosilicon.
Yeah.
But it was later renamed by this guy, Clemens Winkler, who was the guy who first isolated the element and proved its existence. And he's obviously from Germany, as you can tell from his name. So that's why he named it germanium.
Yeah. Well, that's actually a interesting bit of history, is that in the periodic table, Mendeleev was like, hey, I think he specified 3. He was like, these 3 elements are missing from the table. They should be under these groups. And I am predicting these elements. So Ika in Russian is like a prefix that means under. So germanium underneath silicon. Gallium was also Ika boron, I believe, or Ika aluminum. And so basically, if you come up with just like a table and say this is how elements are organized, people aren't necessarily going to believe you at first. So they're like, yeah, right. I mean, look at this iodine tellurium thing. Like, you've got this all wrong. Like, it's inconsistent. But then when people started finding these elements, as Mendeleev predicted, they're like, okay, I guess he's right.
Uh-oh.
So, yeah. So those are your metalloids. Also, astatine is a bit of a controversial metalloid because astatine is a halogen. And the halogens are like super reactive. So people aren't exactly sure. There's a bit of like disagreement on whether it is or isn't a metalloid. But in my chemistry class, it is. So I'm just going to say it is. Yeah. So that's your metalloids. Next we have the newest elements.
Are we moving on?
Yeah, these
Newest
guys.
elements. These are ones I know nothing about.
Yeah.
I know not a single
Yeah, if
thing
you
about
have an
this.
outdated periodic table in your house, I do.
Mm-hmm.
You're gonna see these guys labeled UUH or like UUN.
Mm-hmm.
I do have that actually. Now that I think about it,
UUP, UUO. It's because they were just like unumbium or ununbium. They all just meant that it was an unknown element.
Yeah.
But we've
they
recently
knew it existed, but they didn't know what it was.
Yeah, basically there were
118.
they were unconfirmed. So they had like predicted and they had kind of like discovered it, but they didn't have confirmation of those discoveries. So they put out ununtrium for nihonium, which is 113. So ununtrium, unquartium, ununpentium, like hexium, unseptium, and ununoctium. And then as we as we confirmed the discovery of these elements, we gave them real names, and they're all named after, I'm not sure exactly, but they're named after either people or places. Most of these are named after places, like Tennessee, Japan, Moscow,
Florida.
I don't think, that's the symbol, but FL fluorovium is, I don't know.
Florida.
I actually do not know. So
that's probably a person.
Yeah, I bet Oganesson is too. Yeah, I don't know those though. Yeah. Anyways, I think we're gonna move on to the transition metals. So
the gang's all here.
The gang's all here. Very exquisitely said. The transition metals, these are all your metals. Like, all the buildings, everything, these are made of alloys of these metals, and they're just like, they're like pretty interesting, Not as like the main group's a bit more exciting, but it's really all here when it comes to like construction and stuff. You've got your metals. So we're gonna start with scandium, yttrium, and then these 2 blank spaces that we see on the last slide. So scandium and yttrium, they are elements that have 3 more electrons than a complete shell because they're right after your alkaline earth metals. And basically they want to get rid of these 3 electrons to have a complete shell. And so this is a thing about metals. They tend to come in oxidation states, which basically means they have lost a handful, up to 7 electrons. And they've lost these electrons because they don't really care. They're like, I don't need these electrons. I'm more stable without them anyways, so I'm just going to get rid of them. And so
better off without them.
Yeah, so they give them up to the non-metals.
Sometimes it's like that.
Mm-hmm.
If you're harboring on something that you don't need, that's only a hindrance to you, be like yttrium.
Yeah.
Be like skin.
Be a yttrium.
Yeah, get rid of those
Just
negative
Get rid of what
influences in
you
your
don't
life.
need. What
Get
is
rid of the
hindering you
negativity in your
from
life.
Yeah.
being
And
stable.
be the best version of you that you can be.
Yeah, be
Yeah.
the best version of yourself.
Wait.
Um,
That's coming straight from the Gravity Max live stream, 7 p.m. on Saturdays.
yeah, straight from the Gravity Max live stream. So yeah, scandium, yttrium, they like to be in the third oxidation state because they have gotten rid of 3 electrons. And so also the blank spaces are because of these basically, the lanthanides and the actinides are another group of elements, another type of orbital. I should have said the transition metals are elements that are filling up the D subshell. And so then the lanthanides and actinides are filling up the F subshell. So they kind of just wedge in there and leave these blank spaces. So yeah. So the next elements, you've got titanium, zirconium, hafnium, and rutherfordium. So titanium,
Whoa.
I think I did a project
Titanium.
on titanium in 6th grade because we had this thing about the elements and like we were each given an element.
Then you should know this very interesting titanium. It is the only
let's hear it.
element that will burn in pure nitrogen gas.
Really?
Wait,
It'll
really?
burn in pure nitrogen gas.
It is also found in meteorites, on the moon,
Mhm.
and in some types of stars.
Wow.
Wait, so my question would be, is there... Oh, that was a really dumb question.
What's
I
the
was
question?
about to ask if there's oxygen in titanium. And if that's why it's able to be burned. And then I realized, hang on a second.
It's an element. Yeah.
We've been talking about elements for
Mhm.
2 hours.
Yeah.
You think I would have caught on to the fact that these are elements by now.
Titanium's discovery kind of has an...
It has an interesting story.
It was first discovered by Reverend William Gregor in 1791. And this
He was a
English
reverend.
clergyman enjoyed studying minerals as a hobby. He
Jesus
initially
Christ,
named...
that's a nerd.
Yeah, he initially named titanium monaconite or
Bad name.
menachite,
Get out.
which is a much cooler name
No,
than titanium.
Monaconite? What? Come on, titanium.
Yeah,
That is so much cooler. That
What?
is so much cooler.
Yeah,
Titanium
or
is
it's either monaconite or monaconite.
Listen,
It sounds like a transformer. All right.
titanium
Yeah,
is just...
Titanium.
Dude,
You know what I
it
think
even
of when you
sounds
say
like the sound that make when they're
Yeah,
transformed.
you know what I think of when you say titanium? I think of a pretty sturdy hammer you would get at a dollar store.
That's
You know
what...
what
That's
I think
what...
of when you say monaconite?
That's...
I think of like some giant yellow robot that is gonna like single-handedly take on the Japanese army.
Okay, well, look... Well, the hammer
So, anyways,
analogy,
aimed
that's
at
the
that.
purpose of titanium. Titanium is a light metal. It's not as light as beryllium or magnesium, but it's common in the Earth's core, and it's just used for things that need to be light and sturdy. As I was saying, I had a project where we were each assigned an element, right, in 6th grade. And we had to make like a product based on titanium.
Oh yeah, I had calcium.
Yeah,
I
yeah.
remember
So
that one.
I had to make a product based on titanium, right? And so my product, right, it was a nuclear fallout bunker made of titanium because it's sturdy. I have no idea why I picked that.
Okay,
7th
let's
grade
just
me
talk about the
was
fact
cursed.
that Max got assigned easily probably the easiest one to do.
Mm-hmm. Titanium, yeah.
Yeah.
I mean, just
So
anything
actually,
sturdy.
so after he named it monaconite, this other German chemist, M.H. Kalproth, was like, nah, it's
Yeah.
getting named titanium. And
Yeah.
then the crystal that Reverend Gregor found titanium in was then named monaconite.
At least he got
so
that.
he got the crystal. He was able to name the crystal monaconite.
Yeah.
If you look
Well-
up monaconite, it looks heat. Like it looks awesome.
What?
It looks
Hang
dope. Like look it up.
Hang
Well,
on.
look, speaking of crystals, right? You have zirconium.
Monaconite.
Speaking of crystals, you have zirconium, okay? So zirconium's under titanium, and you might have heard zirconium before. I think the only place someone would have heard of it before would be, I think it's like cubic zirconium or something, which is used as like fake diamond. It's used as imitation diamond. It's a crystal, and it's just a lot cheaper than diamond because,
Oh, I have heard of this.
yeah, because of, you know, I don't want to say the company because I don't want to be like sued for like defamation or something. But there's this one company that has like a global monopoly on diamonds. They're pretty bad people. I think the CEO is like not allowed in America because he would get arrested for violating international monopoly law. So people are like, I'm not going to shell out that much money and support this monopolistic company. I'm going to buy some fake cubic zirconium. But then
here's a quote.
Yeah.
Here's a quote directly from Youie Films because I don't value my channel as much.
No, wait, I can't have it on here though. I can't have it on
Okay,
screen.
fair.
You can
Fair.
put it on
Should
your
I put
own
it in
channel.
chat?
Yeah.
Should I put it in chat?
No,
No.
here's what you can
Okay.
say. Just
But
don't
let's
say the
just
name of the
say,
company.
If you ever
Just don't say the name of the
wanna
company.
Oh, okay. Well, I was gonna put the name of the company in a sentence.
Just say insert name.
Okay,
Whatever you want to say
boomer.
about the company, say insert name or like X company is blah blah blah. Say what you want.
You like that one, Smash? Did you see what I did there?
Wait, no.
What?
No? Okay.
Wait, is it in? Or wait, did you text it to me?
No. Don't. Yeah, I'll tell you after.
Anyways, so yeah, that's zirconium, used as a fake crystal to beat out those monopolistic, companies. So then you've got hafnium and rutherfordium. I don't have a lot to say about them. They're just, you know, heavier versions. Rutherfordium is one of the artificial elements. All of the bottom row of the transition metals, they're all artificial elements because they are very high atomic mass and they just would not exist naturally. So it was named after the scientist Ernest Rutherford, who discovered the nucleus. So it's he's deserving of this name, Rutherfordium. Deserving of this dedication because he investigated through his gold foil experiment where he shot alpha particles at a gold foil. He was like, hey, atoms have nuclei. And, you know, it was all downhill from
That's pretty interesting,
you know?
actually. That is pretty interesting.
Yeah, so...
It's kind of like Avogadro.
Yeah.
And how he didn't come up with Avogadro's constant.
Oh,
He
really?
didn't?
No, he didn't.
Who came up with that then?
I don't know. Hang on, let me look it up.
Well,
What?
Rutherford's deserving of it.
0.02 times 10 to the 23?
Yeah, 6.022 10 to the 23. I have that hammered into my mind. Because actually,
I also have
wasn't it... I don't know if... Okay.
Avogadro's constant was coined in 1909 by physicist Jean Perrine. I'm not saying that one right.
Well...
It was first calculated...
Perrine?
Well, yeah.
It was first calculated by Johann Joseph Loschmidt, a German scientist, in 1865.
But we're not going to
He
have...
actually calculated the Loschmidt's...
We're not going to have Loschmidt's number. Guys, I don't want to get demonetized. I make like 2 cents a video. I don't want to lose that. It's really funny. Well, anyway, so guys, Ernest Rutherford, his gold foil experiment is kind of the foundation of our atomic model. So it's pretty interesting. It's pretty good that he got recognition in the naming of this atom, you know?
Yeah.
So that's Rutherfordium. Anyways, I'm just gonna go ahead to the next slide, all right?
Yeah, go to the next one.
Okay.
Next one. Vanadium.
Vanadium.
Oh boy, this is an interesting one.
So we have vanadium, niobium, tantalum, and dubnium. Wait, what are you laughing at?
I'll be back in a minute.
Okay.
You got it, Matt.
Okay. Okay, so I'm just gonna start. So vanadium is an element that is 5 away from a like complete shell, right? It's 5 away from an empty shell, so it has 5 oxidation states, and this is really interesting. The oxidation states of vanadium, each one is a different color. I don't have it memorized or anything, but basically, as you go through the oxidation states of vanadium, you can see the different colors come up. So, like, as you go from the first to the second to the third, it's pretty interesting. There's experiments where they go through the vanadium.
I have some interesting facts about vanadium if
Yeah.
you'd like to hear them.
Okay, sure. What are the facts?
So here are the facts. Vanadium actually went through a bunch of different names,
Mm-hmm.
and I'm going to do my best to pronounce them.
And all they settled on was vanadium. I mean, gotta say, not the best
yeah,
name.
the first name was panchromium.
Okay,
All right, that's worse.
that's
obviously-
actually interesting because the
Big
next
stuff.
element is
Have I heard
chromium.
that? I feel like I've heard that one before.
Chromium is
So
element
panchromium,
24. Chromium
and
is
then-
24 and vanadium is 23, so that's interesting.
Then erythronium.
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 Yeah, that's a bad name.
Yeah. So then they settled on vanadium.
Okay.
And vanadium gets its name from the Scandinavian goddess of beauty, Venetus. And that was because it was discovered by Swedish chemist Niels Sefstrom.
I guess he really liked vanadium then. Like, thought it was pretty or whatever. If he named it after the goddess of beauty. Also, that sounds a lot like
Well,
Venus.
hang on, let's look that
Vanadianite.
up.
Which is a mineral containing vanadium. It has a very rich red color.
Ah.
Oh, whoa, that's sick.
Yeah, I'm gonna look
It's
that up.
rainbow.
Wait, what's it called?
Vanadium's
Yo, it
rainbow.
actually looks kind of dope.
What's it called?
It's the chameleon metal.
What's it
Vanadium.
called? Vanadium what?
Just vanadium.
Just vanadium, okay. Well, I mean, what was the compound he was talking about? Here, I'm going to look at vanadium
I just looked up vanadium.
oxidation states. Yeah, look at this. I was talking earlier about the oxidation states of vanadium all being a different color. So here they're labeled. The 2 state, the 3 state, the 4 state, and the 5 state. All like, myriad of colors. So then you have niobium, and tantalum and dubnium. I don't have a lot to say about them. Do you have any anecdotes or comments on these elements?
I actually may.
Okay.
So for tantalum,
Yeah.
an interesting fact about tantalum
Mhm.
that
Ooh,
the
here we
website
go.
I'm looking at
Ooh.
for facts
Mhm.
did not think tantalum was important enough to put a fact about tantalum.
That's pretty sad. I feel bad for tantalum.
Here we go. I'm gonna look
Tantalum.
up. I'm gonna look about tantalum.
Hey, can we
Quick.
contact this site and get them to add one? We need tantalum equality. We need tantalum rights.
Here we go. Oh, here we go. What? I'm gonna read off exactly what this says.
Okay.
Tantalum is
Alright.
a strong, ductile metal that is nearly immune to chemical attack at room temperatures. It can be drawn into a fine wire that is used to evaporate metals, such as aluminum.
Well, there you go. That's tantalum.
There you go.
There's your
It's
interesting
used to
fact.
literally evaporate and is immune to
Evaporate
chemical attack.
aluminum.
Wow. So that's
This
pretty
could have been used in World War II,
It could have,
cool. Mhm.
but it wasn't.
but it
gonna
was
move-
not.
I'm gonna go to the next one.
All right.
Moving on to chromium.
Chromium, molybdenum,
Chromium.
tungsten, and seaborgium.
Here's an interesting fact about chromium.
Okay.
Let's hear it.
So rubies are like the gemstone rubies actually get their red color from small traces of chromium.
Yeah. Yeah.
Really?
Chromium is actually
Yeah.
it's named chromium after, like, I don't know, I think it's Greek for the word color because the different chromium
chroma means color.
the different
That's the root.
the different chromium compounds have a wide variety of colors. different
And
colors.
some of them are actually poisonous.
Yeah. We do not condone the consumption of chromium
Do not
compounds.
We do not condone the consumption or ingestion of chromium.
Yeah.
It's bad for you.
So then you also have molybdenum. Molybdenum's interesting. It has stable isotopes.
That's how you pronounce it?
Yeah, molybdenum.
I always
That's just
pronounce it
not-
differently in
no.
my head.
How did
It's
you pronounce it?
Molybdenum.
Molybdenum?
Yeah, that's kind of how I pronounce
Okay. Well,
actually, you know what? I don't. You want to know how I pronounce it in my head? I don't.
it's it's molybdenum, right? So
I just call him Mo for short.
Mo, that's a good one. Okay. So Mo has stable
They call him
isotopes, but Mo is also has some common radioisotopes, and it is like it decays into like it has radioactive decay, and the energy from that decay I think is like used in nature sometimes. So that's interesting. So another one, we've got tungsten. Now tungsten's a really interesting and a very useful one. We'll talk about this a bit later, but tungsten has the highest melting point out of any metal on the periodic table. What do you think about that?
I think that is crazy. And this is one element that can definitely stand the heat. So
Yeah.
it can stay in the kitchen, I guess.
Cool.
Because
yeah.
there's that old saying, if you can't stand the heat, get out of the kitchen. This element can definitely remain within the proximity of the heat, which is present in the kitchen.
Wow.
But I haven't. This isn't even from the fact. So when you see an element where the symbols, like the two letters, don't match what its name is, it's usually based on Latin. But tungsten actually isn't. The W comes from the company that made tungsten very popular in light bulbs, I believe.
Mm-hmm.
I want to grab the name.
Well, I thought it came from the German name Wolfram or Wolfram, but in German they pronounced W's like V's, so Wolfram. That I think was discovered by a German chemist, and he named it Wolfram. And like that's the element, the W. That's where it comes from.
Yeah, that could also be possible. But I remember hearing something that it was like the company that made it like popular kind of named it.
Yeah.
I cannot remember what the name of that company is.
Oh yeah, and I have a science joke. Okay.
Let me hear it.
What do you call the alpha decay of osmium? Wolfram alpha. Which is the math calculator website, Wolfram alpha. Basically, osmium's two elements ahead, and if you were to have it, an isotope of it decay by alpha decay, then you would end up with tungsten or wolfram and an alpha particle. So then you get wolfram alpha. So that's fun. Seaborgium.
That's fun.
Named after a scientist named Seaborg. Like, I think. I don't really know a lot about him. Anyways, so next element.
Yep. He's probably a pretty standard guy.
Yeah, pretty standard.
I'll look him up.
Okay.
Seaborg. Glenn T. Seaborg.
Glenn T. Seaborg. What did he do?
Oh, whoa. What?
What?
There's no way that's right.
What does it say?
What did Glenn do?
So, and I'm not saying this is correct, but in the little Google pop-up box, he is credited with the discovery of plutonium, californium, americium, berkelium, fermium, curium, mendelevium, einsteinium, and bellium.
That might be true.
Don't think.
I mean, it might be.
Is that right?
He might be the lead scientist that was in charge. That would make sense why they would name it after
credited?
him. I mean, he could have worked on the... I'm not sure. Look up if he worked on, like, the Manhattan Project or with nuclear reactors.
Maybe he was just some rich dude who, like, funded the lab.
Yeah, I think he did. He worked on the Manhattan Project at the University of Chicago.
Yeah, that would make sense.
And he worked with where they would later convert uranium-238 to plutonium-239.
Yeah, so that makes sense.
Pretty cool and nifty.
He deserves that naming in honor of him. Did you know they only name elements after dead people? So,
really?
Yeah, so that's why he didn't just, when he discovered plutonium, that's why he didn't just say, okay, that's going to be seaborgium, you know. Elements are only named in somebody's honor. So if you want an element named after yourself, unfortunately, you cannot reap the benefits of saying, hey, an element is named after me until you are dead. So, yeah. Oh. So, yeah, that's kind of sad.
Sorry, I hate to interrupt, but I was gone for like 5 minutes. I was moving upstairs.
Mm-hmm.
What slide are we on?
We are on the chromium slide. Chromium, molybdenum, tungsten, and seaborgium.
We're still on chromium?
Yeah.
Oh my god.
Okay, we'll move on now, though. Manganese.
Let's be real here.
Mongoose.
We all pronounce as manganese.
Mongoose.
Minnesota.
Oh, now I have my outdated periodic table next to my bed.
Nice.
Yeah.
Well, okay, so let's...
So I have some interesting facts about...
Do you now?
An adult human will have a total of around 12 milligrams of manganese in their body.
Of mangooses.
But although we need it to survive, our bodies cannot store manganese.
Mm-hmm.
So
chew on that one.
Where do we get? Chew on that manganese.
Yeah.
Where do we get this manganese?
Don't ask. You don't need to know.
Okay.
It's the government. They're supplementing us with manganese.
Anyways, so manganese, I don't think it's that interesting. I don't have a lot to say about it, but I do have a lot to say.
It gets its name from the Latin word meaning magnet.
Oh, it doesn't come from
actually,
manganese?
I just realized we had a clerical error. Rhenium is labeled 74. It should be 75. I will present again. There we go.
Oh my god. Our integrity has been compromised.
Dude, I think we might have to shut off the stream.
End the stream.
No, we have to keep going until we finish the end.
End your channel.
Okay. So,
thank you so much for watching.
No, okay. Let me talk about technetium.
Make sure to subscribe to Youie Films on YouTube. Great YouTube channel. I upload weekly, sometimes, occasionally.
Yeah, you can do that.
Daily uploads, sometimes once a week.
They're monthly, weekly uploads, right?
Yeah. Okay,
so we've got...
I was supposed to upload a video today.
We've got technetium.
Ooh,
technetium is an element. It's the...
That's how you pronounce it?
Technetium, yeah. It only has radioactive isotopes. It is not a stable element, which is weird because you think of the unstable elements as the larger ones. But technetium is only element 43. So it's like, what's going on? They didn't discover it.
It's like the first radioactive.
Yeah,
it is. It is the first one by like more than a row.
Yeah, so they discovered it in like the 30s or 40s, I think. And they were like, hey, this is a thing. This has been missing. This has been a gap in the periodic table. We found it. And then they were like, cool. And they named it technetium because it was the first artificial element. It was the first element that they had to make instead of discover. So so they named it after technology. So they're like technetium.
That is very interesting, actually.
Yeah, so that's technetium. So then you have rhenium. Rhenium is the element with the highest boiling point. So tungsten has the highest melting point, but then rhenium comes back in last second and has the highest boiling point. So if you want a high temperature liquid metal, go for rhenium. If you want a high temperature solid metal, go for tungsten.
Hey, I mean, the more you know.
Yeah, the more you know, right?
And you would never have known if you hadn't tuned in to the Gravity Max podcast.
Every Saturday, 7 p.m.
This is a podcast, let's be real.
Anyways.
Gravity Max live stream. Every Saturday at 7 p.m.
So, the next element.
If you're not into live streams, you can catch some fire content either on the Gravity Max webpage or on the Youie Films page. You should subscribe.
Okay. The next element is borium. So I guess you can make the boring joke again if you want.
I was about to do it.
Yeah.
I was about to do it too.
It is named after the scientist Niels Bohr, who came up. He was a student of Ernest Rutherford, and based on Rutherford's experiments, Niels Bohr came up with the Bohr model of the atom, which had the nucleus of the atom at the center and had the electrons orbiting around it. That's your classic like clip art image of an atom is the Bohr model. So it's good that he got an element named after him.
So to clarify, he did not discover the element.
He did not. He was long dead, as I said about the naming schemes. But so he elements are actually like weird like blobby shapes with like probability and stuff. But before we had that quantum mechanical view of it, Bohr was like, this is what it is. And it explained a lot. It explained a lot for its time, like electron emission lines and stuff like that. But once we started experimenting with quantum mechanics, we were like, okay, this is a little outdated. But he definitely deserves a place amongst the named elements. So those are those. Now we have iron. Everyone loves it.
This is a classic.
It's a classic.
Yep.
It's a beige ore in Minecraft. It's very useful. It's your mid-tier weapons and tools in Minecraft is iron.
And in Minecraft, an iron pickaxe does 5 damage. I can tell you that is accurate. I got hit in the head with a pickaxe today, and it was painful.
Was it an iron pickaxe?
Wow.
Yes, it was an iron pickaxe. I got smacked in the head with an iron pickaxe. The pointy side.
How are you here?
Because it didn't penetrate the skin. Well, I just bled a little, and now there's a bump on my head.
Well, if it bled, then it did penetrate the skin.
Okay, it penetrated the skin,
just not
but
very
not like
deeply.
Deep.
Yeah. Okay.
Just a very,
deep enough. If you're bleeding, then it deep enough to puncture the dermis.
No. The blood was dissipating through the skin. That's a rare condition. That's what it was.
I'm just gonna take your word on that, I guess. So
we'll go with it.
Let's see. Iron, it's a classic. You've got hemoglobin. Your blood needs iron to do things. Iron is also a very common element mixed into alloys and made into steel. It's just good. It's a pretty strong element. It is also interesting because its nucleus is the most stable nucleus in the universe. Basically,
really?
Yeah. Nuclear fusion in stars stops at iron because if you fuse iron into heavier substances, then it actually takes energy instead of produces energy. So if a star were to fuse iron, then it would just exacerbate the lack of energy that they face near the end of their lives. So, all the other elements after iron are only made in supernovas because in supernovas there's so much extra energy that the reaction can go on without even though it's not a sustained reaction, even though it's not producing energy, there's just so much energy around that the reaction happens anyways. So yeah, iron, really interesting. It's most stable. Anything above iron will be more likely to undergo nuclear fission to produce energy, and anything below iron will do nuclear fusion to produce energy. So that's interesting.
I just want to put in real quick, Max, do you want to check your subscriber count?
Ooh, I shall check my subscriber count. Let's see. I have, it says 511, which is great because I only
511.
I only had 509 at the beginning of the stream. So
it says 512 for me.
Yeah,
512. Ooh, I can release a video after this.
I'm getting 512. That's why I said that.
That's great. I have a subscriber special, so you can look forward to that.
Just thought I would drop that in there. We hit 512 during the stream.
Yeah, that's great. We reached 512. Thank you all.
Nice.
I have a video. It's pretty cool. for 512, which is 2 to the power of 9. Anyways, so then you've got ruthenium. It's just like heavier iron. I don't know. Then you've got osmium, which is the element with the, I believe it's the...
It is the heaviest naturally occurring element. Oh my god.
Wait, what?
Mr. Jones does nothing.
That was
I
lead.
don't know if that's true.
That was lead. Lead was
same
the
thing.
heaviest.
Okay.
No, okay, osmium is the
This is
element...
the metal. It's the
Mr.
heaviest
Jones
of something.
nothing.
Okay, no.
Mr. Jones
Osmium has... Here.
always uses osmium as an example.
Okay, osmium has, I believe it's the lowest heat capacity, which means that it's like the easiest to heat up or something. I'm not sure. I think it might be that. I'm not sure. But anyways, then you've got hassium, named after a scientist.
Let's ask our fun fact man.
Yeah, let's ask her.
You want the fun fact about osmium?
Yeah, let's get a
do
fun
want
fact about
You
osmium.
think you can handle the osmium fun facts? This is not something I take lightly.
Okay.
Osmium,
Mm-hmm.
from the Greek word osme, meaning smell. is
What?
I swear, is a chemical element
Oh my
with the symbol
god.
OS and atomic number 76. It is hard, brittle, and bluish white. It is in the platinum group, and it is found as a trace element
Okay,
in
you're just
alloys,
reading the Wikipedia
mostly
page.
in platinum ores. No, here we
Okay.
go. The
Well,
You're
history
just
of
reading the
osmium.
Wikipedia
It was
page.
discovered in 1803 by Smithson Tennant and
Uh-huh.
William Hyde Wollaston in England.
Okay.
No, are you ready?
Yeah.
Are you ready?
Yes.
Here we go. Osmium
Here, I have one. Osmium has a
capacity.
blue-gray
No,
tint
hold on.
and is the densest stable element.
Oh, it's
It
the
is
densest.
approximately twice as dense as lead,
There you go. I thought iridium was the densest, but maybe that's not. I don't know.
and slightly denser than iridium.
Oh, okay. So osmium's the densest. Pretty much you have this row here, tungsten, rhenium, osmium, of just the number one in various categories for elements. So they're pretty fun. We're going to go
Okay.
to... Oh, yeah. Okay.
Osmium
Yeah.
is
Yes.
loading. The site is loading.
I'm going to go to the next
I'm
slide.
going to some jank. I'm on livescience.com.
I went to the next
We'll
slide.
move on. We'll move on while you.
No,
while
here we
you
go,
get
here we go.
viruses.
Okay.
Osmium is produced as a byproduct of nickel refining. The element occurs in the mineral iridosul and in the platinum-bearing river sands in the Urals, North America, and South America. I want Live Science to block my notifications. While there is little osmium in these products, you can easily obtain from processed nickel ores.
Cool.
Thank you.
Fun fact: osmium is extremely expensive.
Ah. Okay.
And just a little fix to what I said earlier. Osmium, from the Greek term osme,
Uh-huh.
which means smell. A better translation is odor.
Okay.
Oh.
Nice job. Okay. I do want to say, okay, we're going to keep going. I just want to make sure that you guys are okay with going pretty late. Like, if you're okay with going pretty late, I won't rush. But,
I can go for pretty late.
can you go pretty late, Sebastian?
Yeah, I can go pretty late.
Okay, so then there's no need to rush. We'll just have a really long stream.
Yeah.
We're already
I mean,
breaking the
we'll go back
record for the
downstairs at some
longest
point,
Gravity
but-
Max
We'll have a
live
good
stream.
time.
Okay,
Oh,
So-
this. I think in a few minutes it will be the longest
Yeah.
one.
so I've been rushing a bit, so I'll stop rushing.
Yeah, no worries, bro.
Yeah,
Katie.
okay.
No worries.
Okay, cool.
We're on slide
Hey.
25 of 45.
Yeah.
Okay, let's speed it up, huh? Right, I got places to be.
No, okay. The Lanthanides and the Actinides, we won't have much to say about them. So, they're just, yeah. So, okay.
Hang on, I'll be back in a
So the next slide, we have cobalt.
And he never came back.
We have,
You just hear the Discord disconnect sound.
Dun-dun. yeah. So I went to the next slide. Okay.
Yeah.
So we've got cobalt. Cobalt,
Cobalt.
rhodium,
Famously
iridium,
blue.
and meitnerium. Yeah, cobalt is, I believe it's named after like a type of paint or something. Or
Well,
the
I
paint is
actually
named after
have
cobalt.
Some facts right
Ah.
here. You ready?
Let's hear them, yeah.
Cobalt, the isotope cobalt-60, is used to create gamma rays, which are actually used to treat cancer and to sterilize medical supplies.
Nice.
Hang on, what is this? Iridium? Rhodium.
Cobalt.
Cobalt.
Cobalt is used to sterilize medical supplies.
Mm-hmm.
So cobalt gets its name from the German cobalt.
The German word cobalt.
Sorry, wait.
The German word cobalt.
Which means goblin.
Did you just say cobalt comes from the word cobalt?
Yeah, but it's spelled with a K, but it
Oh,
means
okay.
goblin.
Goblin?
It means goblin.
What? That's so weird.
Is this from Live Science?
No,
Wow. Well, cobalt. An interesting fact about cobalt is I thought it was cobalt until I was like, for too long I thought it was cobalt instead of cobalt. Like when I was younger. That's just so weird. Anyways, so rhodium, iridium. Anything to say about those? I don't have much to say. They're like
about which ones?
rhodium and iridium. They are in the classification.
Rhodium
We'll see them a little later, called the noble metals, which is basically they're like rare earth metals. They are very valuable because they don't really like to react with a lot of materials. And this kind of makes sense with their position within the D subshell. They have 7 out of 10 electrons needed to complete a D subshell, which is just an awkward place because 5, like having a half-filled shell is like kind of stable. Having a full shell is also kind of stable, so they don't really know which way to go, you know?
Yeah.
There's also options. Some metals do this. They empty their S subshell to further fill up their D subshell. Manganese, or I believe chromium actually, for example, it only should have 4 in its D subshell, but it has 5 and only has 1 in the S subshell. So things get a little weird, you know, but they don't like to react, and they're very expensive because of these properties. Yeah, so that's interesting. Then you have meitnerium. And meitnerium is named after the scientist Meitner, I presume. I don't know much about Meitner, but he's a guy, and he's got an element
I think I know his last name.
I think it's Meitner, right?
Yeah, that was
Yeah.
my guess.
Okay, cool.
Should we move on to
That
the
would have been
5
my
cent
guess.
piece?
Sure, we'll move on to the next guy. Nickel.
Wait, no,
Oh.
I have a fact.
Oh,
All right, let's
fun
hear it.
fact.
So, fun fact: if you've played Borderlands 1, 2, or 3, you might recognize iridium. Except on the periodic table, it's spelled with an I, and in the game, it's spelled with an E. So the iridium on the periodic table is a lot less baller. It's basically only used in X-rays and nothing else. But it's
Well, I
it can
presume
also
its
be
name
used for
comes from the
tipping
word-
pens and compass bearings.
Ah, okay.
So if you're into that,
Well, I bet its
but
name
in
comes...
game, it's used as a incredibly powerful energy source, powerful enough to levitate entire cities.
Wow. Well, that's interesting, but
It is.
I think its name comes from, like, to irradiate, right? Like iridium, irradiate, something like
That
that.
would be
I
my
can tell
guess.
you. It's actually named Goddess Iris,
Oh, okay.
personification of the rainbow, because of the striking and diverse colors of.
Of the compounds?
Yes.
Okay. Cool. Okay, I'll go to the next slide. So here,
Nickel.
we've got some more
Platinum.
recognizable elements. We have nickel,
And
palladium, platinum, and darmstadium. After the scientist
Stadium?
Darmstadt.
Stadium.
Yeah.
Darn.
They wouldn't name
Stadium.
it that for kicks. It's named after the scientist Darmstadt. Spelled DT, Darmstadt, you know? I think that's a convention in some language, so that's where that comes from. So nickel, used in United States currency.
I have a nickel right here.
You do.
Actually, right in front of me.
Okay.
Wow.
The nickel is my favorite coin.
Really?
Wait, hold on. Wait, this isn't a nickel. This is a nickel.
I don't think
Here we go,
nickels are
everyone.
actually made out of nickel, though.
Oh no, they're not.
I think
Listen
it's
to
fake
this
news.
nickel. That's a quality
Wow.
nickel.
Quality nickel.
That is a nickel.
Not made
You
of
can
real
tell by
nickel.
the
Tails.
sharpness of the sound that it dropped with. A nickel is very clearly the
Heads or
best
tails,
coin.
guys? Heads or tails?
Heads.
What side is up?
Right now, tails is up.
So it's going to be heads,
I'm flipping it.
based on the weighting of a nickel.
Yeah, it was tails.
Okay. Well, anyways, so something I like to think about here, right, is that when you look at the columns.
He leaves.
Oh, okay. Well, okay, so when you look at the columns on the periodic table, like when we looked at our main groups, things in the same column had similar properties. And this is really interesting because it means that nickel and platinum are similar in their properties. So, like, what do you think about that? They're in the same column. And if you think about it, it makes sense because nickel is like a silvery metal, and so is platinum. So they're like similar. Yeah. Yeah. Don't have much to say here.
I have something to say.
Okay.
And Brendan just texted me saying he Wi-Fi issues.
Oh, he's
So
having
that's
Wi-Fi
what's-
issues?
That's what's going on in the background.
Oh, okay. Is he trying to reconnect?
Yeah.
Okay.
So just give him a second. But real quick, an interesting fact about nickel concerning the U.S. 5-cent coin.
Yes.
The nickel is actually composed of 75% copper and only 25% nickel.
What a scam.
Nickel is sometimes added to glass to give glass a green color.
Mm-hmm.
That is interesting.
And alongside copper, when it's burned, it produces a green flame.
Oh, wow, yeah.
I guess. Hang on that
I
colored
think
glass.
boron
thing, it's sort
also
of
makes a
interesting.
green flame when burned. Green
So
flames are
on
just
the
the
glass
weirdest
thing,
thing.
it's sort of interesting how you have to find something that can dye a glass, but not make it
Not glass.
not glass. You know?
Yeah. Yeah.
Mm. So nickel gets its name from the German Kupfernickel, which means
Copper
Which
nickel.
means German.
devil's copper.
Is that German?
Kupfernickel. Devil's copper.
Kupfer.
Yeah, the German word for
Kupfernickel.
copper is Kupfer.
Kupfer.
Yeah, so
Kupfer or Kupfer?
Kupfer.
Kupfer.
K-U-P-F-E-R.
Kupfer.
Yeah.
Okay.
Very
You're taking
cool.
German, right?
I am taking German, yeah.
So tell
German's
that
a very fun language to
tell
learn.
that to your German teacher, Kupfer. Say, the element
All right,
copper.
let's head over.
All right,
to
now
the next-
let's take this-
head over to the next one.
Okay, the next slide is Kupfer. It's copper. Then
Alright.
you've also
This is
got
a stacked slide.
what? You've got
This
okay.
slide has got some serious lineup.
Yeah, this is a really
Copper,
you've got a good
gold,
lineup here.
silver, and then everyone's favorite element.
Just leave the pronunciations to me. Rentgenium.
Yeah, you got it.
Rentgenium. It is named
Rentgenium?
I would have gotten
Rentgenium.
that one first try. Don't even worry about it.
Rentgenium. It is named after the scientist Rentgen, who
Can
also
you like really quick open up a Truly Dead Rock script and then add a character named
Yeah.
Rentgenium?
why?
Can you just put
Oh.
in honorable mentions? Just shout it to my homie Rentgen.
Okay. Well, look. So Rentgenium, the man,
Speaking of
the scientist Rentgen, he also has the unit of radiation named after him. The unit of radiation, the Rentgen, is named after him, and so this element is also named after him. He's got two things named after him. Imagine being that cool that you get two things
imagine.
named after you. The Rentgen and Rentgenium. Pretty cool dude, you know?
Such a relevant
Dude.
element.
Yeah.
Nikola Tesla is shaking.
Yeah, Tesla got no elements. Isn't that a tragedy?
Yeah, that
Hey,
is
he got a car, all right?
Yeah,
he got a car.
Also, he
coil,
wasn't really a chemist.
everything.
He was more of a inventor,
Yeah, that's
so
true.
it makes sense. All these people
Just
are
general
chemists.
nerd and crazy person.
All these people are
So
chemists or like
here's
particle
an
physicists.
interesting fact about
About copper, yeah.
it is the second most highest conductivity.
Oh, you're cutting out a bit.
Okay,
And is gold.
sorry.
But basically, well, it's true. Silver is the most conductive element,
Yeah.
and copper
Silver
is
is the
second,
most
and gold is third. So we have a slide on this later, but these are the most conductive elements. So that's why we have copper.
Rhodium, is that conductive?
Well, there's not enough of it in existence
Oh yeah.
to test it out.
That's why it's gray.
Yeah. So
So
that's
the
why it's gray.
largest single piece of copper ever found weighed
Mhm.
over 520 tons.
Wow, that's
Yeah.
crazy.
Kind of crazy.
Yeah. Well, copper is. Well, so basically that's why we use copper wires, because silver wires would be too expensive, and so would gold wires. So we deal with second best, right? And copper.
The word comes from cuprum, which means cypress.
Ah,
That's
That's
a
cool.
country.
Yeah.
it was discovered
It's,
there, I
it's the
believe.
Latin name for Cyprus.
It was discovered
Let me guess
there.
where it was discovered.
It was discovered.
Yes.
Please hold.
Okay.
It was never discovered.
It's not
Okay. Well,
discovered.
This is a
Copper
route.
has been discovered.
yeah.
Okay.
Okay.
Chaos.
I'm
We
moving
made it
on.
up.
So, gold and
Government
silver. The reason they
Iraq.
where
It
okay.
was discovered in Iraq.
Oh, okay. So I think they found
Mesopotamia / Iraq.
they found large deposits though in Cyprus. Like they have mines or something there.
Yeah.
So anyway,
It's where the Romans mined their copper.
yeah. So if we look at silver and gold, we notice that they have weird symbols, right? And that's because of their Latin names. I will not try to pronounce
Yes,
silver's Latin.
Sebastian.
I don't.
Mhm.
What are you snickering
What
at?
are you doing?
I'm cracking up.
Okay.
About what? The Iraq
I've
thing.
been drawing something in the back, which I'll send to you guys later.
Okay. Anyways, so gold's Latin name is aurum, so that's why you have AU. And then silver
Okay.
is like agi something. I just couldn't bother.
Magnesium.
I couldn't be asked. So those are your elements. Those are those.
Yep.
Let's move on.
That's
to,
your main lineup. Yeah. Okay.
Should we
Next.
move on to?
We've got zinc.
and
We've got zinc, cadmium, mercury, and copernicium, named after Copernicus, the scientist who first proposed the heliocentric theory of the solar system in like the 1500s. He was
What a legend.
a Polish monk, but also an astronomer. And he posted all of his work after he died.
And on Sundays,
On
he
Twitter.
played jazz.
He published all of his work after he died because he was worried that the Catholic Church would not be happy with his ideas of heliocentrism. So yeah. So that's why he deserves it. I mean, it isn't really like he's not really a chemist, I'm not sure, but he was definitely important to
he deserves
science. So you've got copernicium. So let's take a look at these. Zinc, cadmium, and mercury all have low melting points, but of course mercury is famous for having the lowest of melting point of all of them. Of all of the metals, mercury has the lowest melting point, and it is a liquid at room temperature. And that is why mercury is occasionally used in thermometers. Not really anymore though, because people don't want to die of mercury.
no, they use alcohol.
Yeah, a lot boring, more boring. Like.
All right, let me jump in here on this mercury train. All right,
Mhm.
so everyone knows torr, right? Torr, the unit of
Yeah.
pressure measurement, right?
Mhm.
Oh, I thought you meant the browser.
What? That's a browser?
Tor browser.
I think it's
T O
used.
R R.
It's used
No,
for.
T-O.
It's used for
Oh,
like
okay.
the dark web or something.
Yeah. Oh,
Yeah.
right. Yeah. So there, MMHG is torr. It's the same thing.
Mm-hmm.
Yeah.
But I want to promote. I want to promote McGinley's constant. All
Oh
right.
my god.
Okay.
And I think I mentioned it earlier on the stream, but
Yeah, you did.
that was 3 hours ago, so I'll mention it again.
Oh, the square. Yeah. Square root of an
Square rooted
acre.
acres of mercury.
Yeah.
Right? It allows for a
Why?
much more precise
Why?
measurement of pressure. And I think we should change that because there is no standardized pressure unit.
Okay.
So I think square rooted acres of mercury, it would fit in. Look at the units of measurement we use in like chemistry and stuff. Some of that stuff is whack.
Uh-huh.
Spheres
Okay.
of mercury.
Well, okay. So mercury it's really poisonous, like it's really toxic. I don't know the proper word to use. It's bad when it goes in your body. That's really it.
All right. So
Yeah.
Gravity Max.
Gravity Max does not condone the consumption of mercury. Don't do it. Mercury is really poisonous.
don't.
Like, it's bad if certain forms of it can kill you just from a few drops coming in contact with your skin. Other forms are like you're able to touch them, but just generally, please don't do something stupid with mercury. I don't want to be responsible.
If you drink mercury,
Tide
you deserve
Pods.
to die.
No. Well, you will die. That's what happens. Also, the phrase "mad as a hatter" comes from the fact that they used to use
Yes.
mercury in hats. I have no idea why you would need mercury in a hat. It perplexes me.
Wait a second, I never thought of that.
Yeah, right? You always hear that touted about, like, Mad as a Hatter from Mercury. But why would you even have mercury in a hat?
I could not answer that.
I just...
If I'm being honest, I just
What would
could
you-
not answer
like-
that question.
Why? Why would you have mercury in a hat? What would you do with it? But anyways, the people that made hats just died from mercury poisoning from dealing with mercury. And it, like, one of the symptoms of exposure to mercury is insanity. So they became as mad as a hatter because of mercury. Because for some reason they were putting mercury in hats.
Why do you need to put mercury?
Yeah, wait, I want to look that up.
Yes,
Why
please.
do you
It's actually frightening me now. I won't be able to sleep if I don't know why on earth they would put mercury in a hat.
Why do you need? Okay.
What do they say?
Why did people put mercuries in hats? Okay. Mercury nitrate
Uh-huh.
was used in the process of turning the fur of small animals such as rabbits to felt.
Okay.
It was used to make the
That's
felt.
not a
Alright.
valid reason. Just use scissors.
All right. You know,
Well, turning squirrel
I'll
fur into
begr-
felt can't
I'll
be done with scissors,
begrudgingly
bucko.
accept that answer, although I don't like it. I don't like that answer. How do they make felt now?
that doesn't seem like it's justified.
Yeah, I know. Anyway, so another thing in this group, zinc. People think pennies are made of copper. They used to be made of copper until copper prices went up, so now they're made of zinc with just a thin lining of copper on the outside. Pennies are 95% zinc, 5% copper, which is interesting because it lowers the melting point of a penny. If you try to melt a penny, which is technically illegal, so Gravity Max does not
It is
condone the
committing a
melting
felony
of
to
pennies.
destroy U.S. currency.
Which is honestly kind of stupid. I do have to say they should have gotten rid of the penny because it costs more to make a penny than it does
It does.
in value. So
That's a fact.
when people started like melting down pennies just for scrap metal, the U.S. government should have been like, "Good on you, you're doing our work for free." Instead of recalling these pennies and melting them down to get rid of the useless currency, you're doing it for us. Nice job. But instead, they're like, "No, we will not permit this." So it is what it is,
As
right?
one does.
Yeah. But anyways,
This is why
Which is how it
capitalism is
be.
not the answer.
yeah. So this is our last transition metal. So now let's go to the types, like the little
Oh.
groupings. First, we have the refractory metals. Now, the looser term includes the gray elements, but the stricter term only includes the like black, the bold ones. So
All right.
these are our like really strong metals, which are our tungsten, rhenium, and osmium. High melting point, high density, just really tough, strong metals that you would use for those purposes. I don't have much to say here. They're just very metallic Like when you think of a metal, this is what you think of. Yeah. Anything to add?
Yeah.
Yep.
I do have something to add,
Okay.
Max.
Yeah, what do you have?
Let's hear it.
Which slide are we on?
The
Refractory
metals.
metals.
Okay. Osmium. No, not osmium.
Another
We're
osmium
going to
fact.
hafnium. We're going to hafnium.
Hey,
Okay.
get that dub. Get that dub.
We're talking the hafnium.
Okay.
Hafnium.
Yep.
There's this kid who
Hafnium.
went to my camp whose last name was Hafner Schnee, and that's all I can think of whenever I hear that element.
Okay.
So, what is hafnium used for? Well, let me tell you. It's a great absorber of neutrons, and it's
Ah.
used in the control rods of nuclear reactors.
Mm.
Hafnium is also used in vacuum tubes as a deader, which is a material that combines with and removes trace gases from vacuum
Nice.
tubes, not cubes. I'm tired.
I'm also tired.
I am as well.
Hold on,
tired.
it comes from the
But I'll
Greek.
keep going. Let's keep going, boys.
Hold on, Greek. The name comes from Jack Nowhere. They used to call it hafnium.
Okay. Well, those are our refractory. Let's move on to the noble metals.
Noble metals.
We've got ruthenium, osmium, iridium, rhodium, palladium, and platinum. So as I said before,
All right,
these...
can I talk about?
Oh
platinum
wait,
real quick?
no. I found its name. Hafnium is named after Latin name of Copenhagen.
What? You cut out.
You cut
It was
out.
named after Hafnia, which is the Latin name for Copenhagen.
Oh, okay.
Cool.
Okay, cool.
All
So
right, let me talk
anyways,
about platinum real
Okay.
quick,
we have
right?
14 more slides.
those will go
Platinum
quicker though.
Is platinum? Everyone knows what platinum is, right?
Yeah.
Uh-huh.
It's a really common name. You've been hearing platinum since you were like a kid, right?
Yeah.
What
Got
is
my platinum
used
medallion
for?
status at Delta. Fly Delta, Sky Miles.
What is platinum used for?
I don't know.
It is a metal.
It's
It is.
a noble
not,
metal.
Not like METAL, like MEDAL.
Yeah.
It's a metal.
It's like better than gold.
It is better than gold.
Mm.
And I can tell you a fun fact about it. Ready?
I would love to hear
Yeah.
a fun fact about some platinum.
So this guy came up before. Shout out to anyone in the comments. Here's how this guy popped up before. But William Hyde Wollaston of England.
I can't even remember when he popped up.
I
Yeah.
don't even know.
Discovered.
Didn't he like? Oh, I think didn't he like? He did a thing earlier.
Yeah, he did something else. I can't.
He
I
did.
can't.
Something with the elements.
Yeah. Okay, so it is the most ductile of the pure metals,
Uh-huh.
and it's pretty malleable.
Uh-huh.
And its malleability allows it to be pounded into a sheet as thin as 100 atoms.
Oh yeah, I've heard of that.
Oh, that's
And
actually really cool.
Platinum gets its name from the Spanish word platina, which means silver.
Cool.
So it's
Okay.
silver.
Well, yeah. So these elements, they don't react. So they're good, right? They're cool. Also,
Yeah,
this
we're
is the
good on
same
this.
thing with the stricter
Conductive
definition
metals.
and the wider definition. Yeah. Okay. I'm gonna go to the next slide.
Oh, I want to send you
Oh.
guys what I've been drawing.
Okay.
Yes,
Anyways,
do you see what I texted you?
what?
Yeah, I did. That was great.
Okay. Anyways, so our next slide is the conductive metals. We've got copper, silver, and gold. I mean, we kind of talked about them before. This slide is kind of redundant, I realized in retrospect. But yeah, as we said, very conductive. They're used in wiring, especially copper because it's cheaper. But I believe, don't they use a bit of gold and stuff like the plating of like astronaut helmets and also in like iPhones and stuff like that? They use it in phones.
Yeah.
Like trace amounts, not a lot, because otherwise it would be super expensive if they used a lot. So that's your interesting noble metal stuff, or interesting transition metal stuff. So now we have our
Sebastian, I
lanthanides
really appreciate that drawing.
and actinides. We
It's
have
good.
I'm
It's good.
okay. We have our
Max, you
lanthanides
wanna
and
put it
actinides.
up on screen?
What? I'm
Put the drawing up on screen.
gonna have to take a look at it first on my phone.
All right.
Well, so what do you think about the lanthanides and
It's,
actinides?
it's PG, don't worry.
Oh, okay, it's fine. Okay, here's what it is.
I drew that.
Manganese.
Mangy.
Oh my god.
This man has clearly had too much manganese. We do not condone the consumption of manganese.
You can
Okay.
actually eat it. Just don't eat
You
too
are
much.
Don't
supposed
tell him
to
that. Okay.
You're supposed to eat it.
Anyways, oh, you are? Okay.
All right.
Oh, yeah, that's
Lactation
true.
and actation.
So,
No, wait. Lanthanides.
okay.
And
Lanthanides and actinides. What? So, here's an interesting thing about the lanthanides. The lanthanides are mostly natural. Like, the lanthanides are all naturally occurring. The actinides are mostly artificial. The first few are naturally occurring. But the lanthanides, the naturally occurring elements, it took them a while to discover them because they just couldn't figure out how to separate them. They were so similar in chemical properties and in mass that they just could not figure out how to separate these elements until they had like advanced equipment. So it just took a while to discover them, you know?
Yep.
Yeah.
These are the two rows that you see shoved
Yeah.
into the
Yeah.
bottom.
These are the
This
rows
is
you
the one where
ignore
you
pretty
look at-
much.
Look at it and you're like, God dang,
Yeah.
that's kind of annoying.
Yeah. These are the rows you ignore.
All
Um,
of the ones on the bottom are radioactive.
Yeah, the
Yeah.
actinides. The lanthanides, I don't believe, right? They're
None
not.
of, no, one of them
Polonium
is
is radioactive.
promethium.
Promethium?
Promethium, you're right. Not polonium.
Yeah, promethium. That would make
Sorry, I
sense.
have one. I have one
Promethium
right here
and
on my left.
technetium. So there's a concept in the periodic table called islands of stability, which are basically elements that are slightly more stable, like amongst very unstable elements. But I think you can also argue that you have the opposite, islands of instability, which would be technetium and promethium, as they are unstable elements in amongst relatively stable ones. So that's interesting.
Yeah.
So we're gonna go through these a bit
It
quick,
is.
because we don't have much to say. Lanthanum is the first of the lanthanides, and it is, I mean, that's what the lanthanides are named after. Like, I mean, what else, right? Then you've got cerium and praseodymium. I really don't know much about them. Do you have any fun facts on cerium and praseodymium? I do
You
have
know
to
what?
say,
I just
praseodymium is a
might.
long name.
You just might have one
might
of
have
those.
just
Let
might.
us hear it.
Here you
Yeah,
go.
let's hear it.
Oh, I
Cereal.
was about.
Yes.
No, it's not related to cereal, but it
And you
is.
shouldn't eat it.
Yeah,
Yeah,
do
you
not
should
eat
not
cerium.
Eat
Gravity Max does
Gravity
not.
Max
Yeah, okay.
Say it
anyways.
with me. Gravity Max
Gravity Max
does not condone the
condone
consumption
the
of cerium.
Consumption of
or ingestion
ingestion
of cerium.
of cerium.
How is that? The
Cerium
come out of this stream.
was
bro?
discovered in Basnas, Sweden,
Okay.
by Johns Jacob Berzelius and Wilhelm Hisinger.
Okay.
And the name they come up
1803.
with was cerium. Are you kidding me? Just
No.
use one of their
Honestly, I'm
last
glad
names.
they picked
And then,
cerium and
okay,
not
so
some
after
crazy thing.
those two, this other guy claimed he discovered it, named Martin Heinrich
Uh-huh.
of Germany,
hmm
and cerium was actually the first of the lanthanides to be discovered, even though it's the second of the lanthanide series.
Yeah.
It is a decent element,
Okay.
and it can be used in gas mantles.
Great.
Really?
Anything to say on praseodymium?
Praseodymium.
hmm
Sounds like a dinosaur.
Yeah.
Yeah. Praseodymium. Jesus.
What?
Praseodymium is actually a very it is it comes from the Greek prasinos or prasinos,
hmm
meaning green, and didymus, meaning twin. So, it is the third member of the Lanthanide series.
Okay.
It was discovered. Again from Basnas, Sweden, and this guy named Wilhelm Hissinger found it, sent it to this other guy named Carl Schiel, who looked at it.
Cool.
And then they found it.
Nice. All right, I'm going to go to the next one.
It is used in...
Oh, okay.
Yep, all right. That sounds about
next
right.
one. Okay. So, we have neodymium, promethium, and samarium.
Ooh, I know neodymium.
Yep. Do you want to say it? I've got something on my mind. I think we all know where this is going. Magnets. Yes. Neodymium magnets are famous for being the most powerful.
It's that strong, expensive magnet that all the cool kids have. And they're like, look at my neodymium magnet. It has a magnetic pull of 500 pounds.
Yes.
And then you take the magnet, you put it on a piece of iron, and you're like, good luck, nerd.
Yeah. Basically, neodymium, super strong magnet. Really just intense, like... really strong magnet. It can harm you if you have your hand between two neodymium magnets. That would not be good. Yeah, they're just really strong magnets. You probably see a lot of YouTube videos where people are like playing with my neodymium magnets, and it's like, okay. So
it's like, okay, how do you have 10 times the amount of subscribers I have?
Anyways. So then we got promethium, which is named after Prometheus. And that's all I have to say about Promethium.
I was about to say, I only know that name from a JonTron video.
Yeah.
And it is because he calls Phil Swift his Prometheus.
Wow. Well, Prometheus is basically in Greek mythology. He stole fire from the gods so that humans could have fire. And that's why we have fire. Because this guy Prometheus was like, let's get fire. So, honestly, I think he deserves an element.
He said, let there be fire.
Yes. I think he deserves an element. He discovered fire. Not really. I mean, it's mythology.
Correction,
so.
He invented fire. He invented fire.
No, he discovered it. Supposedly. According to Greek mythology, he took it from the gods. The gods were, like, happy on their high horse. They had fire.
We should make a Greek mythology stream.
Yeah, that would be good. Except it would probably be like 10 times longer than this, and this is already long. There's so much there, you know?
This isn't even that long. We just probably should have started at 5.
Yeah, maybe. Anyways, so then you got samarium.
You can't mess with 7 p.m.
7
p.m.
7 p.m. on EST.
We're just going to keep going,
Saturday
though. Keep
PM.
plunking along. Anyways,
Hosted by Gravity Max and Sebastian Molino.
Yeah.
The guest this week is Brendan McGinley. Subscribe to Youie Films on YouTube.
Yeah. So, samarium. Do you have any fun fact about samarium? Because I don't have much.
Good Samaritan.
I do. It's my initials.
Oh, that's true.
That is the symbol.
Oh.
Cool. That's enough. Cool.
Do either of you guys have your initials?
No. I do not have my initials. There's no MR. I do have rubidium. Sounds roughly like Rudin, like Rubid. So I kind of like to think that's my element.
Okay, boomer. Europium.
Oh, yes.
Are we moving on?
Yeah.
Europium.
Europium, named after the continent Australia. Gadolinium.
Named after Africa. Europium is a very...
Yeah, gadolinium. Named after a scientist named Gadol. And then terbium. I think also that's a scientist. Or tuberculosis. I don't know. One or the other.
TB.
Yeah.
Or named after Mr. Terabyte.
Terabyte. Yeah. So something like that. So yeah.
Terbium.
Oh my god.
Here's an interesting fact about terbium.
Okay.
It's used for nothing.
Okay.
All right, Max, you can do this one. You can say.
Oh, you again, like lithium, you can cut it with a knife.
Oh, okay.
It was, oh my god, it was discovered in Sweden. Everything was discovered in Sweden.
The Swedes are the kings of the Lanthanides, I guess. Cool. Do we have anything on europium or gadolinium?
I do.
No.
Check this out.
Oh
Check.
my
Okay,
god.
what is it?
Europia. Oh,
No.
it was discovered
Yes.
in
In Europe.
Africa.
wait. Discover.
I'm gonna start crying.
Where was Europe?
Okay, it was.
Just say it.
I don't. It's not even telling me where.
Okay, we're going to the next one. Okay.
No.
Okay.
Europium
Yes.
discovery.
Oh my god.
I swear. You know what? I'm just gonna look it up. I'm gonna.
It
Look
was. Where is it found?
Oh my god.
The sun.
Europe.
Okay, we're going to the next slide.
It was
No.
found in Europe.
Wait, give me a sec.
Sebastian, it was found in Europe.
It was found in France.
It's called.
Found in France. Good. Okay. Cool.
It's
So
So
not Europe. France. Ha.
okay. So after these three, we have dysprosium, holmium.
Is that
And
how you say
erbium.
that?
You might notice that erbium is terbium without the T.
Sounds like. I was about to say.
Yeah.
And if it
Didn't
was
make that easy
herbium,
on us.
It would be mumbra
What?
backwards.
Moim.
Oh, what was that?
Moimbre. Okay.
What was that loud sound?
I
Okay.
think we're all losing our minds.
Yeah, we're kind of
Definitely.
losing our minds.
Talking about the periodic table for 3 hours.
Yeah, that's true. Come on, we've got to finish this. We've started this,
Let's
so
power
we've got to
through.
finish this.
Yeah,
Oh, it's not
Any
a question
interesting
of if we're gonna
facts on
finish it.
any
We're
of
gonna
these
finish
three?
it.
Dysprosium, holmium, or erbium?
No,
I have something.
don't know.
Okay, what do you have?
Holmium.
Yes.
Named for
Yes.
Homer Simpson.
Sherlock Holmes.
no.
Sherlock Holmes. Homer Simpson.
Whoever gets the closest guess before I find it wins.
Okay.
Holmium. Dr. Holmes.
The concept of a home.
Sherlock William. Sir William Holmes the Third.
It's
Justin
Holmia,
Holmes.
the Latin name. Because
Sorry,
it
you
was
cut out.
You
What was
cut
that?
out.
Holmia, the Latin name for Stockholm.
Oh, okay, for Stockholm. Let me guess, was it discovered in Stockholm, Sweden?
Let me check
Stockholm Syndrome.
that.
Uh-oh.
It was discovered.
Where?
In. Give me a sec.
Okay.
I'm gonna keep looking for it until Brendan starts freaking out.
Oh my god, please just find it. Why does it take so long?
Stockholm, Sweden.
Okay, great. So,
Thank you.
our next
Move on.
our next
Please,
three-
Can we
the-
please
I have
move on?
something for erbium.
oh, okay.
Erbium
I'm gonna kill
Erbium. What's about erbium? What do you have to say about erbium?
was discovered in Sweden.
They're all just Sweden, okay? Okay, Sebastian. Only tell us if it wasn't discovered in Sweden, okay?
Okay.
If it wasn't discovered, and it
Just for these.
Discovered in the same town
please
as-
tell us.
As yttrium
Okay.
and terbium.
Okay, let's go here. Okay. The next
Okay.
elements.
Thulium.
Thulium. Ytterbium.
Thulium is usually described as the nicest element.
Why?
That's just not.
Oh
that's
my
gosh.
What?
Thulium,
No,
Yt-
you gotta look at it.
thulium, ytterbium, and
The
lutetium.
thulium is a nice element.
So, okay,
Alright.
listen. Here's an interesting fact. Ytterbium and yttrium, from all the way back in the transition metals, are both named after the same town.
Yeah, that's the same town that erbium
Okay,
was found
thank
in.
you.
What was
What
it?
about
What's the town called?
Lieutenantum?
What's the town called? It's like
It was called yeah.
Yitrer.
Ytterbia. Like what's it called?
Give me a sec.
Utka.
Uh,
Bonk.
uh
I I think I've
It
gone.
was
insane.
discovered in.
I swear to God, Sebastian, please.
Give me a sec.
Just hurry up.
I'm finding it.
Also,
Ytterby.
and
Ytterby.
Ytterby? Okay.
Yes.
Also, it's funny, thulium is TM, so it's trademarked. So no one can say thulium except for the discoverer of thulium. So I think we're going to get a copyright strike.
I'll tell you who the discoverer of thulium is.
No, we're good. Okay. Next elements. The next elements are...
it changed. Oh my
The
God.
discoverer was
Was
Swedish.
that half of them? Was that half?
Yes, that was half of them. That was
Per
half.
Theodore Cleve.
Cool, okay.
That
So,
was half of them.
now we start on the actinides. We have
I'll be back in a
actinium.
minute. I'll be back in a minute.
No, you gotta stick it out. You gotta
I
stick
have
it
to go to
out.
the bathroom.
Okay,
No, you got it. You got
let him, we'll take a...
I'm going to the bathroom.
Okay,
Sebastian.
I'm gonna keep
Leave
talking.
me
Just
be.
go. Okay.
I haven't gone to the bathroom in 3 hours, and I have drank so much water.
Just go. You should have gone during break time.
That was like 2 hours
Okay.
ago.
Listen. Just
You're like
go.
those teachers that are like, why
Yeah,
are
I
you going
know.
to the
Why
bathroom
didn't
in
you
the
go
middle of
during-
class? Why
during
didn't you
lunch?
Go to the bathroom at
Okay.
the start of class.
Okay.
Miss Moore.
Just go, and I'm gonna talk for a bit, and when you come back, just whatever. Okay. So we start on the actinides. So these are named after the first element of the actinide series, actinium. And after actinium, you have thorium and protactinium, because they couldn't think of another name. They just added prot in front of actinium and got the next element. What do you think of that, Sebastian? Wait,
That's cool.
Yeah. Do you have any facts? So thorium's interesting because it can be used. Uranium's the typical element for nuclear reactors, like that's what we think of. But thorium might actually provide like a cleaner way for nuclear reactions to react and get energy from. So thorium reactors are an interesting concept.
Yep.
Like,
you'll never
yeah.
discover where it was discovered,
Where?
or you'll never guess
I'll
where it
never
was
guess.
discovered.
Where was it discovered? Is it
Norway.
Sweden? Norway.
Yeah.
Out of left field, Norway just comes in and
Well,
is
it was also named after Thor.
the god of God of
Obviously.
thunder, right? So that's interesting.
All right, let's go over to the next one. Uranium is cool.
Uranium,
It's got-
Neptunium, plutonium.
I can talk about uranium.
You've got the 3 elements
go
named
ahead.
after
All right,
planets.
uranium. So back in 6th grade, this
Oh,
is
yeah.
how I met Max.
Wasn't this
right?
7th grade?
No, because I would have known you
Oh yeah, that's true.
because of
Media-
workshop.
Yeah, and media club.
Yeah.
So 6th grade, we were. This is the story. We were in
We
orchestra.
wanted to build a nuclear reactor.
Yeah,
Long story short,
TLDR. But basically,
it
we were.
wasn't even a
If
joke.
you look at this, I swear this is at the
What?
top. These are all my tabs. Google Drive, this slideshow, Ducksters.com, this live stream, my email, Tantalum Fact, Tungsten, Seaborg Manhattan Project,
Oh, God.
Osmium, Iridium,
Why are
where
you not
was copper
closing your
discovered?
tabs?
Yeah, close your tabs,
Hafnium,
dude.
John C. McGinley, Cerium, Praseodymium,
Hang on a
Terbium,
second. Hang on a second. Hang
Yttrium,
on.
Thulium Discovery, Thorium.
Your FBI agent must be like, dude, calm down.
Yeah.
Oh, chill.
Anyways,
Yeah, it's just like I'm not getting paid enough for this.
okay.
I feel bad.
So,
for the
yeah,
agent
we
who
were
has
in
to work
the-
on Sebastian.
We were in our middle school's orchestra. We both played the violin, and we were having an orchestra field trip to go play somewhere. And so then Brendan comes up to me, and he's like, hey, do you know about nuclear physics? And I'm like, yeah, I know a bit about nuclear physics.
I think it was, hey, you're smart, right?
Well, I didn't
Do you
want to
know
say
anything
that.
about
That's what I was
nuclear?
thinking, but I didn't want to say that because that would be, conceited.
I know. I think the first thing I ever said to you was, hey, you're smart, right? Do you know anything about nuclear physics?
Yeah.
And then I told you, hey, we should build a nuclear reactor.
Yeah.
And you promptly researched nuclear reactors, planned the entire thing. And I said, yes, I understand, while understanding approximately none of it.
Approximately. Oh my gosh. So that was fun. I'm glad we didn't actually build it though, because
I found the drawings.
Oh, you did. Wow.
I found the drawings a while ago. It was they were not detailed. It was like a
were they your drawings or my drawings?
A line in the middle.
What?
My drawings.
Oh, okay.
It was like a circle with a line in the middle, and it was thorium-235, and then the outside was labeled lithium-6.
Oh, okay. That would be the blocker. That would be the what's it called? The control rod. Yeah. So, okay.
Yeah.
Uranium is the last naturally occurring element. It is still radioactive. Like lead was the last stable element, but uranium's the last naturally occurring. Elements can be radioactive and naturally occurring. Okay? Let's just clear the air on that one, right? So, plutonium was discovered during experiments with nuclear reactors because they were like, hey, when we do this stuff with uranium and make energy, it also makes plutonium in like small quantities. And this is also useful for making energy and explosive stuff. So then they used it.
Oh my God. I'm sorry to interrupt.
Yeah.
But you know Team Trees?
Yeah.
They're at 4.1 million.
Trees planted?
In a day.
What?
That's pretty good.
Wow.
$1 million raised in a day.
Nice job. Good for them.
Yeah, good for them.
Mr. Beast donated 100,000. Alan
Nice.
Walker 100,000. Mr. Beast another 100,000.
Wow.
Dang.
Anyways, so those are your elements, right? So now let's go to
Yes.
americium, curium, and berkelium. So
Let's
An
do
American.
americium is
it.
named
Americium.
Americium. It's named after the United States of America. Right? I'm pretty sure. It's not like North America or
It's
something.
Americium.
Americium.
Oh, Americium.
So
Shut up.
So curium is named after Mary Curie, who did work with radioactive elements and actually died of radiation poisoning because she was doing like the first work with radioactive elements. So like no one really knew that like it's not good for you. So she just kind of like died from that. But she made a lot of discoveries.
Sucks.
Her and her brother, I think, like they were like
Her and her husband.
Oh, her husband. Okay. Her and her husband like did some chemistry and nuclear investigations, and they first like discovered radioactivity pretty much. So that's pretty interesting. Then you've got berkelium, as I said before, named after the college Berkeley because that's where it was discovered, in a lab at Berkeley. Anything to add?
All right.
Anything you guys want to add?
Nope, I am good. Let's move on.
I have some facts.
Let's let him add his
I'm
facts.
joking. I'm joking.
No.
What are your
I have a
facts?
30-minute monologue about this one.
Wait, which one? Which one?
I do not. Don't worry. I don't actually have a 30-minute monologue.
Wait, which one? Americium?
It's a joke. I do not have a 30-minute
I think he
monologue.
does.
All right, let me talk about why capitalism is the only realistic solution.
Okay,
Oh, no.
okay. Next element. Next
Okay,
element.
next elements. We don't want to be controversial here. Yeah. I don't know.
Let's talk about why church and state shouldn't be
All right,
separated.
next
Oh
element.
no. Okay. Californium, Einsteinium, and fermium. Californium is named after California. Einsteinium is named after
Thanks.
Albert Einstein.
I'm glad it took us 3.5 hours to get to this point.
And fermium is named after the scientist Enrico Fermi. Enrico Fermi, who you might know him because his namesake is used in the Fermi
That
paradox.
might be the best joke I've made all video.
To get to this. But yeah, so Enrico Fermi coined people named the Fermi paradox after him because he basically asked, if space is so big, where are all the aliens? Little did he know the answer was Area 51.
And if you do want to learn more about this subject, there is a great video on it on this subject
Oh yeah.
on Vsauce.
On Vsauce. There's also
Just
great
kidding,
videos
there's a good one on Gravity Max.
What? Well, there's also great videos about the Fermi paradox on this YouTube channel, Isaac Arthur, Science and Futurism with Isaac Arthur. That's got to be like one of my favorite YouTube channels right now. It's really great. They're like half-hour episodes on like space and futurism and stuff. Yeah, it's great. They come out like weekly. You should watch it. I mean, he doesn't need help from like 512 subscribers, but yeah, great channel. If you like this channel, you should check out that channel. So, those are these three. I'm just going to move on. You've got Mendelevium, Nobelium, and Lawrencium. So, Mendelevium is named after Dmitry Mendeleev, the discoverer of the periodic table. It took until element 101 for the man who started it all to get an element named after him.
Wow.
It's kind of like the series arc, don't you think?
Hey, at least he got it. I'm still waiting for Youie.
These are the last... Youie. These are the last...
For the great YouTube channel, Youie Films, you should subscribe. Why Youie Films?
These are the last 3 actinides, and I feel like it's fitting. These are the last elements that we have to talk about. And I think it's fitting.
Then it will be released from this cage.
Oh my god.
Well,
wait,
we have a bit
actually?
more, but...
Is it actually?
Okay.
Oh my
well,
god.
We have a little more, but basically, so Mendelevium, it's come full circle, you know? He started it all, and he's got an element named after him.
He's gonna end it all.
That
came out wrong.
Yeah. He's deserving of the element named after him. If anybody is deserving of an element named in their honor, it is Dmitry Mendeleev. So he's got element 101. So
okay, I agree. Let's move on.
Element 102 is named after Nobel, who also has a certain prize named after him. The Nobel Prizes.
No.
He was also the inventor of dynamite.
Yeah, he invented dynamite, and then people inevitably used it for its destructive powers. I mean, I don't know how he didn't see that coming.
Here, wait. Let me take this one. Take this one. All right.
Okay.
Stop talking.
Okay.
All right. So Nobel, right? He invented dynamite, and he made hella money off of it. He would employ his family, but then like people were dying in his factories because it was really unstable, and people would blow up in their factories.
Yeah, not fun.
So he was really rich, but no one liked him. And they accidentally said that he died in a newspaper. And in the obituary, everyone was like, yeah, I didn't really like him. So he read that. And he realized that no one liked him. So when he did die, he donated all his money to start the Nobel Prize. And everyone was super shocked, like, whoa.
Because he wanted to leave something positive.
Yeah. So because they falsely said he was dead, everyone said, oh, yeah, no, I don't like him. And then he did a thing.
Wow. So, yeah, Nobelium.
What a guy.
Pretty good guy, you know. I mean, he invented dynamite. He had good intentions. He thought it would help with something. But honestly, if you invent an explosive, I mean, I don't know how you don't think it's going to be used for explosions. Sorry, not to throw shade against Nobel, but, you know.
I don't think he'll care.
Yeah, I don't think he'll care. Anyways.
I think he's dead.
I mean, not to throw shade against the prize show. You know, you don't want to not get a Nobel Prize because you made a pass at Nobel, do you? Honestly, any of us are gonna get a Nobel Prize. Like 2 people.
I'm gonna get a Nobel Prize.
You're gonna get it?
Watch me.
You're gonna get a Peace Prize?
Yes, I'm gonna get a Peace Prize.
Peace Prize is probably the easiest to get because it's like the most, like it's the least certain, you know? Like science, it's like discoveries and stuff. But peace is a hard concept. Because technically someone that like took over the entire world and created a new world order has brought peace to the world.
Or I could nuke North Korea when I become president.
Next element.
Yep, Lawrencium. Lawrencium. So, named after Lawrence, for the Lawrence Livermore Labs in Berkeley, where it was discovered. So we'll go to the next slide now. Here we have our nuclear reactor fuel. We talked about this a bit before.
Nuclear reactor fuel.
But thorium, uranium, and plutonium are the main elements used in nuclear reactors.
Plutonium is most notably used in Back to the Future.
Yes. Plutonium is used in Back to the Future to go. He
steals it from the Libyan.
He stole it from the Libyan nationals. Not a good idea.
Not a good.
Would not.
did not
Gravity
turn out well.
Max does not.
Gravity Max does not condone
9 out
stealing
of 10
plutonium from
doctors do
Libyans
not
to produce a
support
time
stealing
machine.
Plutonium from the
Yeah.
Libyans.
Okay,
Makes for a
so
pretty good cinematic.
now we
universe.
have a website that I want to go to. This is
P table.
this is the dynamic periodic table. This is a very good website for periodic tables and such. You can
guys
translate
down
it.
to spend an hour on this site.
No, we're not going to spend too long on it. You can translate the periodic table to whatever language you want, including, say,
I kinda
like
wanna
German,
translate it to German.
Deutsch. So
How do I translate
you can
it?
have Deutsch, German elements,
Deutsch.
phosphor. It's interesting. They cut off the
cut
enes
off the
for the
names.
halogens. Also, hydrogen is called Wasserstoff, which I think is a very good name.
Electron. Okay.
What? Electron spelled with a K.
It's
You also get that.
Wasserstoff,
I'm going to go back to English because that's the
Helium.
language I speak.
lithium, beryllium, bor,
Bor,
Kohlenstoff,
Kohlenstoff. I'll go back.
Stickstoff,
Stickstoff,
Soystoff,
soy
Fluor,
stuff, fluor, neon, natrium.
magnesium,
Magnesium.
aluminum, siliconium.
Well, it's
phosphor,
silicium,
Spice,
phosphor,
Zweifel,
schwefel,
chlor, argon,
chlor, argon.
calcium, calcium, scandium,
Okay, you can stop.
titan.
Please stop.
Okay.
Cease. Iron is ison.
Sure.
Anyways, so you can go to properties and you can see what state the element is in at any given temperature. Then you can also take a look at their melting point, and you see the redder it is, the higher the melting point. Boiling point too, the redder it is, the higher the boiling point. Electronegativity, which is pretty interesting. As you can see on the right side, you have really electronegative elements, and on the left side, you have really not electronegative elements. So these elements try to get electrons. These elements try to get rid of electrons. Then electron affinity is like a similar concept. Valence electrons, which is the electrons they have available for bonding. Then you have ionization energies. You have radius, so like the size. Yeah, you got all this stuff. Conductivity. Oh yeah, conductivity is an interesting graph. Look at our 3 conductive metals, just like super green, and everything else is like white, maybe tinted green. So they're like really conductive compared to everything.
Hang on, I have a question.
Yes.
Yeah.
So on the P table thing, right?
Yes.
If you set it to 0 Kelvin,
Yes.
helium is a liquid.
Very true.
Is that a thing?
I think it just doesn't go solid.
Huh.
Yeah. Liquid helium
That's
is
pretty cool.
very
It is
strange,
the only
though.
element that does not
It's a
turn
superfluid,
into a
right?
solid.
Doesn't it? Like, oh, also you can go into wide mode. Wide mode.
Wide mode.
Wide mode.
Me.
The best mode. Wide mode.
When you look at Sebastian, wide mode.
Wow.
Seriously. These character assassinations will not be tolerated. Anyways, so then you have orbitals and electron configuration. Remember the weird thing I was talking about? So look at this. Vanadium has 3 in the D subshell. Then chromium has 5 and has taken 1 out of the S subshell. And then manganese has 2 in the S subshell and 5 in the D subshell. And it's just kind of crazy, don't you think?
It's crazy, bro.
Copper also
It's
finishes
just crazy.
it.
Wide mode.
Copper just jumps and gets rid of an electron in the S subshell. So it's pretty interesting. Pretty interesting stuff.
I would say.
Then you've got isotopes.
Final thoughts?
Isotopes.
Final thoughts?
Wait, 1 second. I just need to go through the tabs. Isotopes. You can see all the isotopes of an element. Compounds. You can look at the compounds of the element. And back to the slideshow. Okay. Okay.
Yeah. Okay.
Final
Yeah. Let's
thoughts.
keep going. Let's hit it.
Final
Hit it.
thoughts.
go.
What do you think? So, in summation, how do we summarize these 3.5 hours we've spent?
Oh my god! I
Starting
could've been-
off like a
Yes.
jovial
What?
thing that trumped up by Jigsaw.
Wait, sorry, what? Repeat that?
This was a good stream.
This was a good stream. Longest
It was,
Gravity
it was.
Max stream.
There were some good moments. There were
Good
some
moments,
funny jokes in there.
definitely. It kind of devolved as we went. It started off more formal,
Yep,
serious.
Sleep deprivation. I think we should do an episode.
Sleep deprivation.
Max
kicked in.
and I have
Wait,
been wanting to do a podcast that starts at 12.
Wait,
and
you want
goes
to do?
to
Oh
1
yeah, I
for
remember
a
that.
while. He was trying to get me to do that, and I was like, "No, I'm not doing that."
Yeah, wait. So what?
That's the
you want to
only
do?
time I ever. That's the only time I wasn't the one coming up with the bad idea.
Yeah, you owe me for the nuclear reactor. Anyways, yeah, we can do
Wow,
a episode
I see
at
how it is.
what,
You
midnight?
owe me for an episode at midnight.
Well, what?
what
That's
do
what
you
you
owe?
said. That's what Sebastian said, isn't it?
No, I was just thinking that we could just use like this stream as like a focus point, or we could do
What
a
do you
stream
mean?
kind of similar.
What do you mean a focus point?
If you want me to ever come on this show again,
Uh-huh.
it better not be 3.5 hours.
Okay. I
No, actually, this was
apologize.
fun. This was.
It's
fun.
not that
This
late
was
though. I
fun.
mean, it's 10:30. Come on.
It's not even that. It's
Yeah.
not even that late. It's the fact that I've been interacting with people for 3.5
That's
hours.
probably
Yeah,
I
true.
don't do
That's
that on
true.
a normal day.
Yeah.
I spend maybe 30 minutes interacting with people.
Uh-huh. Okay. Well, so what were you saying, Sebastian, about?
I was just thinking like we could. I like the idea of doing like a 12-hour stream.
a 12-hour stream starting at 7 p.m. and going
that
to
is
7
something I
a.m.
would be down for. No, not starting at 7. Starting at 12.
12 p.m.
Okay.
Wait. We
Either
might do
from
one
noon
at.
to midnight or midnight.
How about starting at 5 p.m. going to 5 a.m.? We might do that in the future, maybe. We could
What would
do.
we even talk about for that? Like all of modern history, leaving out.
Bro,
I don't know. We'll think of
Remember-
something.
Remember,
We'll think of
this-
something.
remember the birthday party we had where it was an all-nighter at Max's house?
I do.
I think that was, like,
in
all of
such
them.
a deep sleep after that. Like my mom, like to wake me up, like kicked me in the ribs or
No.
something, and that
Oh.
didn't wake me up.
Wow.
Whenever I stay up for a long time and then I sleep,
Mhm.
it's always an awful night of sleep, and I always sweat a ton,
Yeah.
Mhm.
and have awful
It's always the
dreams.
sweat that gets
Yeah.
you.
And you wake up and you're like, why am I sweaty? Why am I cold? This sucks.
Yeah.
Not
I-
fun.
I always actually my bedtime is 9 o'clock. This is self-imposed. I go to bed at 9 o'clock because I have school like early in the morning. My school starts at 7:20, and it ends
Our
at
school
1
starts at
p.m.,
11:30.
which is pretty good actually. It ends at noon pretty much because
Wait,
1 p.m.
what?
1 p.m.
Hang on a
Which
second.
is
Hang on.
when I say
Hang on
noon,
a
I mean solar
second.
noon because
I'm starting to see some perks moving to Florida.
yeah, the place I live, we have like solar noon is later in the day, so the sun rises later and sets later. And so solar noon is around 1 o'clock, and I'm out of school by then. So it's 7:20 to 1 o'clock, which is only 5 hours and 40 minutes. And that's just because our lunch period is technically like 7th period. So it's like the last period of the day. So we technically have lunch at 1, but everyone just leaves. So
Oh,
it's interesting.
well.
So yeah, we have
We
6
don't have
classes.
that. We have school until 2:15.
Yeah, I
And me-
remember.
Sometimes I have to end my day with quadratics.
Oof.
Do you know what I never want to do?
End your day
You know what
with
I'm never
quadratics.
psyched to go do?
End your day.
End my
yeah.
day by learning how to solve quadratics. See, I'm at the point in the math curriculum where
Mhm.
realistically I will never have to use this after school.
Yeah,
Once you get past geometry, you're done. You're set.
unless
as long
you're
as you stay
working math.
refreshed on that, you're good.
Yeah,
Unless you work in math, obviously.
yeah.
I saw this TED Talk, and did you watch it, Sebastian? Did you watch the School Kills Creativity TED Talk in Connections?
I don't even remember how to breathe.
So he brings up this point that if you do what school wants you to do, and if you follow all the rules, realistically, if everyone turned out the way school intended them to,
Mm-hmm.
everyone would be university professors.
Mm-hmm.
University professors are those people who actually paid attention to school and actually always did what the work was.
Mm-hmm.
Yeah.
That feeling
Just
when I
something.
want to be. Yeah, I mean, I would
I could
probably
see Max as a university professor
eventually.
in something smart. Then I could
Yeah,
see
you see what I
Sebastian
wanna
as
do?
a university professor in gender studies.
What?
What?
Out of here.
Well, anyway, this is my idea. My idea is to work in like physics and like in the science, in the stuff like maybe in finance and stuff like that. And then once I'm like older, then to be a university professor in physics. Once I have
So
done that.
I'm going for a really well educated position. Like I'm gonna have to go to a lot of school for it. I
Mhm.
want to be a live TV director.
Ah,
So I'm gonna have to get a lot of degrees for that, and
this is
probably
practice
drop out
then.
of school, take a job, and yeah, no, I really need no education for that. I just need practice.
Yeah, so this is fun. So maybe you might want to join us when we have our 12-hour stream.
I will definitely join you guys for. I
Yeah.
will anytime you guys want me on. I will join.
Cool.
Yeah. This
Don't
was
That's great.
fun, even though we kind of
Even though,
insane at
yeah,
the
we
end.
went over the time. We kind of, yeah. But Brendan, yeah, we will definitely have you back on the stream. You guys, if anyone's still watching, you'll see Brendan again on a stream. Next week, I don't know.
You just lose like 100 subscribers.
No, it was great to have you on, Brendan. Next week, we're probably going to have a different guest, I think. We're going to ask another one of our friends, to be the guest on the show. And then maybe after that, Brendan can come back and like we can have multiple people on. So
maybe next time you'll have a Pluto on.
Oh yeah, Pluto.
Because that was a very successful video that got a lot of views.
Pluto video. That
video did
was
so
Brendan's
poorly.
voice. You should go check out Pluto video because that was Brendan. So he talks about the history of the dwarf
Sebastian,
planet.
do you want to watch that video?
We can do that later though. Let's just end the stream.
But when I can
let's-
read again, I will.
Let's just end the
No,
stream.
no,
Okay.
actually,
So
let's-
thank you for being here, and thank you, Sebastian, as always, for being my co-host on our live stream.
Always.
Tune in next week, Sunday, 7 p.m.
Sunday, 7
And
p.m.
just
EST.
final message to everyone: do not consume like most of these elements.
Don't
Yeah,
consume.
Gravity
any
Max
Most
does
of the
not
things
condone
you
the
said,
consumption
don't do
of
it.
most of these elements. Okay. Anything else? Anything
And
else?
our last comment was
Anyone else
Johan
say?
saying 3 hours in.
Nice.
A bit more. It was our final total is 3:38.
Yeah.
Awesome.
So
Thanks, everyone.
I'm gonna hit end stream. Thank you, everyone. Thank you for watching. If you watched this long, and
You're
if you
all
want to watch
beautiful
it back,
people.
you can do that. Thank you, and see you next time. End stream.